I'll throw in the ladder. If you guys buy 65-inch telescopes, I'll throw in a ladder for you.
Ladder's free.
You think that would be a good sales pitch? Includes free ladder.
You buy the scope, we give you the ladder. All the ladder you need, ladder by the foot. Yes, I like it. Your ladder to the stars. It's
That's right.
It writes itself.
That's right.
Absolutely.
You need to trademark that. I'll be back. I need to call my lawyer.
Yes. Yeah. Stairway to the stars.
Or Stairway to Heaven.
We might have to. Yeah. I mean, Robert.
Never get copyright infringement for that.
No. Oh no.
Jimmy Page might demand a look through the scope. Yep.
Mm-hmm.
Now it's that other band that had that copyright suit against them for Stairway to Heaven.
Yeah.
Was it called Spirit or something like that? They
Yeah, I
didn't
think
have it
so.
against them. It was, I can't remember. Anyways, the fights.
Yeah, it was against
rock and
Led
roll
Zeppelin for
bands.
stealing the chord progression.
Yeah. Who was the rapper who stole the bass line from Under Pressure? Remember that? Queen got a big payoff for that.
I don't know.
Yeah, that was Vanilla
Remember that?
Ice.
Yeah, Vanilla Ice. Yeah, he had to cough up a few millions to Queen as if they needed more money. Yeah.
Right.
Yeah, I'm sure Vanilla Ice needed the millions though. So
He had to buy more.
Vanilla Ice, if you're listening right now, I think you're cool. So
Vanilla is expensive. You have to scrape it off a tree bark.
that's right.
He needed all the coin he could get. Who was the first guy who discovered that? If we scrape this paste off of this bark, it's really yummy. Huh? These are the things I wonder about. This is why I never got into any of the really good schools, these thoughts.
Oh,
I think you got into a very good school, David.
let's
Oh,
stop
thank you,
Eicher
David.
now while we can.
Thank you, David.
Mm-hmm.
Where did you graduate from, David?
I went to Miami University. It was established, believe it or not, by George Washington in southwestern Ohio. It finally got going in 1809. And it was a little school that was like a high school until the 1830s and expanded, where my father taught for many years, chemistry, but not in 1809, much later on.
Yeah.
When John was there.
I want to tell you why your school was so good. They years ago used to have a telescope at that school.
Yes.
It was a beautiful 12-inch
Yes.
Alvin Clark refractor.
Yes.
And at one point they decided they didn't need it anymore.
Yep.
And guess who they donated it to?
Leslie C. Peltier.
Yes,
Yep.
they gave it to him.
Can you
Yes.
imagine that? What a
There was a
connection
phone
that.
call on the line, and they said, we'd like to donate to you a 12-inch refractor,
Yeah.
Alvin Clark lens. And boy, was he excited.
Oh, can you
Yeah.
imagine getting a call like that? Yeah.
With observatory and transit room.
And thankfully, Leslie actually did some really, really great stuff with probably not too much happened when it was in Oxford, that telescope.
Probably not.
Yeah.
But Leslie did a wonderful, wonderful things with it.
Yep.
And
What a
he likes
connection.
to describe how that telescope and his 6-inch refractor would talk to each other after he went to bed. And the refractor would say, the 12-inch would say, I can see 16th magnitude stars. And the 6-inch would say, yeah, but you can't catch a comet.
Nice.
Very nice. Hello, Chuck. It's good to see you.
David,
Chuck,
both Davids, how are you doing?
good and
Oh,
yourself?
fine.
Good to see you.
How goes the league tonight? Everything in order?
It continues to teach me a great lesson in life, and that is that the secret to life is moving from one failure to another without losing enthusiasm.
Oh, come on now. Come on now.
No, the league's doing great. We've got a delay on the website. It's aggravating us a little bit. And we're hoping in the next couple of weeks, 2 weeks maximum, we'll be able to review it and get it going.
Oh,
So-
good. Yeah, boy, is it hard to find developers these days.
Well, we found a good developer, but
Good.
we're trying to merge the store with the website, and we have a lot of databases, award databases, membership databases, and getting all that incorporated has had some difficulties associated
Sure.
with it. So
Tricky business, yeah. It sounds like things are getting close, though.
they're very close.
Good.
This particular quote from Neil deGrasse Tyson is pretty poetic in itself, you know. It may be that our cosmic curiosity is a genetically encoded force that we illuminate when we look up and wonder. I like that.
I like it. It's a little touchy-feely, but
It
then again,
is.
you know, you think of the earliest hominids who we derive from were around about 6 to 7 million years ago. Clearly, you know, they looked up and saw the moon and things like that and must have thought in some way, you know, what is that? And, you know, as brains got bigger, you know, we tend to think of past generations long ago as fundamentally stupid, but they weren't. You know, a lot of our ancestors, they were reasonably smart, but they lacked technology and experience. You have to think that for many countless generations, our forebears looked up and wondered what these things were, you know, and
Sure.
so there's some truth in geneticism and encoding there, I think, from this.
Right?
What I like is from Jill Tarter. We, all of us, are what happens when a primordial mixture of hydrogen and helium evolves for so long that it begins to ask where it came from.
Nice. Yeah,
Nice, Jill.
that's great.
Now, Jill Tarter will be at Starmus, won't she?
She will indeed. Yeah, she is
Wow.
on our board.
Wow.
So you will meet
Cool.
her.
That's very cool.
She's wonderful. She's really, really wonderful. And you know, her perennial sidekick, Seth Shostak, you
Yeah.
know him.
Mhm.
He's one of the great guys.
Oh,
in the
Seth is
field.
funny.
Yeah.
We'll have to get him on Global Star Party pretty soon.
I'm sure he'd love to. Yeah.
Yeah, he's been on Global Star Party once before. So,
Yeah. He's a brilliant guy. And of course, Jill is a genius.
yeah. Wonderful. Well, I guess we're ready to get started, folks. Here we go.
Scientists used supercomputer simulations to throw 8 different types of stars at a monster black hole. Their goal is to create more realistic models of tidal disruption events, which occur when unlucky stars stray too close to black holes. Gravitational forces create intense tides that deform the stars and break them into streams of gas. These simulations are the first to combine the physical effects of Einstein's general theory of relativity and virtual stars with realistic internal structures. This schematic shows the star's trajectory. In this version of the simulations, the black hole has 1 million times the sun's mass, and the stars are about 24 million miles away at their closest. The model stars range from about 1/10 to 10 times the sun's mass. The colors reflect their densities, from the lowest, shown in blue, to the highest in yellow. In some cases, the stars are fully pulled apart. In others, they're only partially disrupted. As these stars move farther from the black hole, their own gravity pulls them back together. Surprisingly, the stars that fully and partially disrupt aren't cleanly divided by mass. The Sun-like star, along with those with 0.15, 0.3, and 0.7 solar masses, survive their close encounters. But stars with 0.4, 0.5, 3, and 10 times the Sun's mass are completely torn apart. The difference between survival and destruction depends on the star's internal density. Simulations like these will help astronomers build a better picture of these catastrophic events occurring in galaxies millions of light years away.
Well, hello everyone, and a big howdy out to our audience out there around the world. It's great to have you guys logging in and checking us out. We have an incredible lineup for the 90th Global Star Party, starting with David Levy. We'll move on to Chuck Allen from the Astronomical League. We've got David Eicher, editor-in-chief of Astronomy magazine, with more minerals and crystals of planet Earth. We've got John Briggs, who's going to introduce and talk about the history of adaptive optics, but he's going to introduce Dr. Robert Q. Fugate, and he is the father of laser pointed artificial stars, I guess, for working on large aperture telescopes for adaptive optics. So it's pretty exciting. And he's, from what I understand, an incredible astrophotographer as well. Daniel Higgins from Astroworld TV and Shawn Nielsen from Visible Dark will be on together. It's awesome. We got Adrian Bradley and someone new also, Lisa Ann Fanning from the Royal Astronomical Society of Canada, the Halifax Center. She'll be on. Jason Guenzel, the Vast Reaches, rejoins us. Of course, Marcelo Souza will be there with us to talk about Skies Up magazine and what's going on with his new event that's coming up here in a few days. Cesar Brollo joins us back again, and he's going to be talking about the Star Party Valle Grande 2022. So that's pretty cool. And of course, Maxi Falieres with Astrophotography to the max. So we'll get started now with your friend and mine, David Levy. David?
Well, thank you, Scott, and it's really good to be here, and especially to talk about the cosmic flow that is our theme for this week. And for a poem to introduce the cosmic flow, I was thinking back to Shakespeare, and I wanted to ask how many of you have seen the Omega Centauri star cluster. I think a lot of you have. David has. Just about everyone on the Zoom session has, and I'll bet you a lot of you Facebook and other people, listeners and watchers, have seen it as well. Rick Hill called it, "Oh my God, Centauri." It is a beautiful cluster, and it's probably the most beautiful globular cluster in the sky. It is so beautiful and shaped like a lovely oval that some people say it's not a globular cluster at all, but the remnants of an external galaxy that interacted with the Milky Way somehow, but we really don't know. For my quotation today, I go back to William Shakespeare, and he wrote Julius Caesar, and as he was sitting down in his study writing the final words, they find that Brutus has been killed, and he writes his famous "This was the noblest Roman of them all" speech. And after he's done, He closes his book, he goes outside, and he sets up his Explore Scientific telescope. And he takes it and he looks up at Omega Centauri, and which is a bit of a tough bird to try to find from the latitude of London. So he sails a little bit further south so that he can see it. And then after he sees it with his Explore Scientific reflector, he writes these words. This was the noblest star cluster of them all. All the star clusters, save only he, did what they did in envy of this great cluster. He only, in a general honest thought and common good to all, made one of them. His life was gentle, and the elements so mixed in him that nature might stand up and say to all the world, this is a star cluster. Thank you, and back to you, Scotty.
Thank you so much. Yeah, absolutely. You know, the first time I saw Omega Centauri, I mean, it's almost a heart stopper. You know, you just can't believe that your amateur telescope can be flooded with stars like that. You know, and it's just it's spectacular, and it takes a while after the initial shock of seeing this thing, if it's your first time, to kind of let it absorb in, you know, and you just go, wow. And then it's just, there's a tranquility and a beauty of it, especially if you got a real wide field eyepiece, you know, you've got this concentration of stars and it's spreading across, and it's just, it's a great place just to kind of stay on, sort of hover in, you know, and to just wonder at the amazing illumination of all of that. So thank you so much, David. Thank you.
Thank you, Scott.
Yep. Okay, so up next is Chuck Allen. Chuck has been with the Astronomical League for decades and has supported them in so many different ways and so many different roles. But the role that I always fondly remember him is when he was president of the Astronomical League, and we got to talk about and share our enthusiasm for supporting young astronomers. You know, and the Astronomical League, I think that is one of the organizations that does it best. They recognize them, they nurture them. And, you know, we have been honored to, you know, do what we can to help support that a little bit. But it really is the strength and the venerability of the league that has helped encourage young people to, you know, change, to inspire them to learn more, you know, to become scientifically more literate. Some of them have gone on to be, through their exposure and their recognition from the Astronomical League, have, you know, taking up studies in astrophysics, and I think it has bettered their lives. So, and in so doing, you know, I think it makes the world just a little bit better every time that they do that. Of course, I'm speaking about the National Young Astronomers Award, and Chuck can tell the story better than I can, but I've been honored to participate in all that. I also want, you know, every time I want to give a nice shout out for the Astronomical League. They are a constantly growing organization, over 300 clubs in their federation, over 20,000 members, and you know, all the individual clubs that make all of that up really make a powerhouse organization when you think of all of that together. So, Chuck, thanks very much for coming back on to Global Star Party.
Well, I think that's my line, Scott. You're inviting us to be a part of this for these last several years has been a great benefit to us. 30 years ago, when I came up with this National Young Astronomer Award program, it was Scott who jumped in 1 year later and started providing amazing telescope prizes to our winners. And he's still doing it now 3 decades later, and has made this program really sail. So deepest appreciation to Scott for all you've done for us over the years.
Thank you. It's been an honor.
Let me share screen here. One thing, when young people get involved in astronomy, we like to make sure that they protect their vision. And mistakes can be made, especially when you're starting out in astronomy at a very young age. And some of those mistakes can result in permanent eye damage if you're not careful. Observing the sun can be done safely, but you need to be very careful about certain things. I won't touch on all of these, but certainly never observe the sun without professionally made solar filters that include energy rejection filters that go at the front end of the telescope, not the eyepiece end. You don't want to use a solar filter or welder's glass that attaches to the eyepiece, for example, because heat can build up in that eyepiece in that filter and burst it. Don't leave a telescope or binoculars unattended where other young people might try to acquire the sun. And I've actually seen someone try to do that. Be very careful about using eclipse glasses. Make sure they're certified or from a reliable source. The Astronomical League can help you with that. And never use eclipse glasses for anything other than direct viewing through the glasses only. Don't use them with binoculars or a telescope. I think Scott did an experiment with some eclipse glasses by placing them over an eyepiece through which the sun was shining, and they melted almost immediately. So be careful, consult local amateur astronomers, and you can do this safely, but you have to learn how first. We'd like to, first of all, cover the answers from a week ago, from April 5th. And here were the questions. Which four-letter word beginning with N is a star, showing a sudden large increase in brightness, then gradually returning to its original state over a period of weeks to years? The answer is nova. And the second question from a week ago, whoops, wrong way. Titania, Miranda, and Bianca are all moons of which planet in our solar system? And the answer, of course, Uranus. And the third question from last week, in space or astronomy, the Big Bang machine is another name for what? And the answer is the Large Hadron Collider. All right. The correct answers from last week are these 8 individuals. And I will let you just read the names. These names will be added to the door prize list at the end of the month. Okay. These are the questions for tonight. Please send your answers to secretary@astroleague.org. Secretary@astroleague.org. That email address appears at the bottom of each slide. I'd like to start off by the first question by showing you an image from an Edmund Scientific Catalog in 1969. Quite a bit before 1969, my first telescope when I was 7 years old was a 3-inch Edmund reflector just like this. And I use 20 and 12-inch telescopes now, but some of my greatest memories were first views through this. And one night in October of 1956, I was trying to observe a number of objects and tried to observe a certain galaxy that was very large on the charts. In fact, it was huge on the star charts. And for some reason, I just could not see it. And I was very frustrated by this. I went to bed. And I just stewed in bed. I'm 8 years old. Why couldn't I see such a large galaxy in the sky? So my bed was right up against the window on the second floor. We didn't have air conditioning in those days. So I raised the window and scooted out on my back so that my neck was on the sill. And I took a pair of binoculars and looked straight up at the fall constellation where this thing was. And boom, there it was, a thumbprint smudge, very obvious in binoculars. And it was then in October of 1956 that I learned about surface brightness and how it relates to what you can observe. And that object is pictured here. And so our first question tonight is, this is the second closest spiral galaxy to the Milky Way, identified by one of its 2 popular names or one of its 2 catalog designations. Again, the email address is down below. Whoops, sorry. Now this object on the surface of Mars was discovered by Christian Huygens in 1659, and it was the first surface feature ever detected on Mars. For many years, it was thought to be a plane of some sort. It measures about 930 miles vertically and about 620 miles wide. And it extends north from Mars's equator. The Mars global surveyor, however, determined that this was not a plain, but actually a shield volcano with a very gentle slope of about 1 degree on average. So what you're seeing here is dark basaltic rock from a shield volcano on Mars, very large shield volcano. And so the question is, what is the name of this conspicuous dark area, originally thought to have been a plain, now known to be a shield volcano at the center of this image of Mars? Okay. Finally, former planet Pluto was the subject of considerable controversy back in 2006 when the International Astronomical Union decided that it was no longer a planet in a vote that was taken during their convention, I believe in Prague that year. They established 3 criteria for a planet: 1, that it orbit the sun, and 2, be massive enough to collect itself into a spherical shape, which Pluto qualified for in both cases. But it was found that the 3rd criteria, the ability of a planet to clear its orbit of other objects, that Pluto failed this test because of other TNOs in its region and Neptune itself. So the International Astronomical Union is the world organization of professional astronomers. And question number 3 is, what is the US organization of professional astronomers called? Okay, and again, answers to secretary@astroleague.org. Please join us on April 15th at 7 p.m. for yet another event that Scott so generously hosts for us, and that is the Astronomical League Live event. We have John Wenskovich, who will be talking to us about Lagrangian points and the James Webb Telescope. He will explain to you how an object can orbit absolutely nothing in space. And so we'll look forward to seeing you then. And Scott, thank you very much. We'll return it back over to you.
Very nice. Thank you very much. Yes, it is a little bit hard, I think, for people to get their heads wrapped around the Lagrange point too. So I would join that group. But it's amazing that we were able to figure it out, and I look forward to hearing his talk during Astronomical League Live. So that's going to be great. We will turn our gaze from the sky back towards Earth with our good friend David Eicher. He is the editor-in-chief of Astronomy magazine. He is an incredible rock hound as well, and someone that understands the universe not only through the lens of a telescope, but through the lens of crystals and minerals. I like the way I said that last time, so I'm just going to say it again. Okay, so anyways, David Eicher, thank you for coming back on to Global Star Party and sharing your minerals and crystals with us.
Thank you, Scott. Thanks for having me. And I will see if I can share my screen. And while we were sitting here over the last few minutes, Maxi sent us a beautiful image. Can you see my screen?
Yeah.
A beautiful image of Omega Centauri. And let me share it with you. Can you see the cluster? And I will just add very briefly to what David beautifully said, and that is that we do now know that Omega Centauri is the defunct nucleus of a dwarf galaxy that encountered the Milky Way gravitationally. And now is the largest and most massive globular cluster in the Milky Way. It has a mass of about 4 million suns. So lots of stars there. And as anyone, you guys, I think I've done it probably with Scott and with David and maybe with some others here. Literally, we were down at the Texas Star Party looking at this together. And in one of those big daubs like Scott makes so nicely, you can see this cluster and it's almost as if you're orbiting this thing. It's such a beautiful sight. So you definitely want to try to see Omega Centauri at some point if you can. And now I will stop sharing, and I will try to share a different screen. Oh dear, there we go. Yes. Now let's see if this works. And
Yes.
now we'll come back to Earth, and I will see if I can start a slideshow. And you'll either be delighted or horrified by the fact that we haven't gotten through all the minerals yet. But we're working our way through. There's some element of randomness here as well, because tonight I'm going to talk about aluminum and barium minerals. And sometimes the groups of images that I have together, without getting into a resorting of hundreds and hundreds of images, kind of represent what's on a display shelf together. So that's the only thing that's going on here, really. Between aluminum and barium, but we'll look at some common minerals of the many, many kinds of both that are principally made up of those important elements. As we talk about each time, the universe is ordered. Thomas Jefferson said, I believe in a divinely ordered universe. Long before Jefferson's time, Isaac Newton, one of the principal founders of modern science, gave us the quotation, truth is ever to be found in the simplicity and not in the multiplicity and confusion of things. And the universe is ordered not by supernatural design, as our pal Richard Dawkins likes to say, the universe doesn't need to be magicked into explanation, but by the principles of physics, which in an ordered way show us what's really happening. Minerals demonstrate this because their atoms are assembled in precise ways by electrochemical attractions, inherent properties of the atoms that make them up and guide them into assembling in what mineralogists call a crystal lattice that brings these crystals together. When they get disordered, ground up, moved around, and lost and pulverized is when they turn into rocks and other stuff like that. But the universe likes to make things in an ordered way, and that's what minerals show us. So we can talk for one thing about aluminum minerals a little bit tonight. Of the many, many, many kinds of aluminum related minerals, corundum is an important one because it's well known by a couple of other names, and it's a simple one too. It's aluminum oxide. It was named corundum in 1725 by John Woodward and derived from the Sanskrit kuruvinda, which is the word for ruby. Richard Kirwan used the current spelling, corundum, by 1794. It was known by many names in antiquity: adamant, sapphire, ruby, hyacinthos, asteria, and so on. It comes in many colors: colorless, blue, red, pink, yellow, gray, golden brown, and others. It's the aluminum dominant analog of several other minerals, the common one of which is hematite, iron oxide. And the red variety of this, which is colored by contamination of chromium atoms, is ruby. And the blue contaminated version of this, which contains iron and titanium atoms, is called sapphire. And those are very well known, of course, because they're super hard minerals and they're good, they're pretty, and they're good for making jewelry. The crystallography of corundum is trigonal, and of course it has aluminum and oxygen atoms in this kind of a lattice that come together. And crystals are made like this whenever the material is available in the right way, at the right temperatures and at the right pressures and the right abundances, usually in hydrothermal fluids that will flow in rock and accumulate these atoms and make crystals, but not always. Barium is another important mineralogical producer. The most common barium mineral is barite, which is, I'm using the official, which is the English spelling here with a Y because the International Mineralogical Association, not giving away any clue for Chuck's quiz here. This is mineralogists. Spell it, they accept the Y spelling. It's spelled in the United States ITE though. It was named in 1800 by Dietrich Carson from a Greek word for heavy because of its unusual weight for a non-metallic mineral. It's very heavy, holding a small size, even partial hand size sample of barite. You can feel how heavy this stuff is. It comes in a lot of colors as well, including colorless, but white, yellow, brown, gray, blue, and so on. It's typically found as a thick to thin tabular crystal, usually in groups or clusters, with crystals that grow parallel to each other and also as bladed masses as well. So it's a very common mineral too. Barite crystallography, it's orthorhombic, and you can see its crystal shape with barium, with sulfur, yellow, and oxygen atoms as well involved in those crystals. So again, as always, here are just a few examples of what some of these things look like from a typical struggling editor's collection. Here's a corundum. This is a variety of corundum we would call ruby, although it's almost transitional here between ruby and sapphire with this kind of purpley pink red. Here, this is a Madagascar specimen that also has a lot of mica biotite in it as well, this black stuff. And this shows you kind of the natural way that ruby crystals often are found in nature before they are cut, of course, by jewelers, which horrifies mineral collectors because we want to show the minerals as they are naturally. Here's a small ruby, but a very nice colored ruby specimen from Vietnam. This was one of the first minerals that I got in the modern era after my father contaminated my mind with interest in this, among many other things. Remember, collectors, you can never turn back. You can only collect more, whether it be books or, you know, observations of the sky or minerals or what have you. So you got to be committed because you'll never go back. Here's another example of a ruby. This is also with black biotite, and you can see little tiny almandine, sort of honey-colored crystals. Those are little members of the garnet group in there as well. This is a Russian specimen from a very well-known locality there. Now we get into some different aluminum minerals. This is called wavellite, and I threw this in there for Scott. This is aluminum phosphate hydroxide hydrate, and this is from a very well-known area of quarry in Montgomery County, Arkansas.
All right.
The best locality in the Western world for wavellite, which is an unusual phosphate. Good stuff. That sort of lime green color. This is a turquoise, which is a copper aluminum phosphate hydroxide, also very popular, of course, for jewelry. This comes from a famous old gold mining town where there was so much turquoise around, they didn't worry about it. And in the old days, even when I was a kid, you could go out to Cripple Creek, and when there was a rainstorm in the streets of Cripple Creek, Colorado, you could see the little blue-green bits of turquoise flowing down in the little areas around the roads. There's so much turquoise there. So this is a little piece of turquoise from Cripple Creek. Here's an unusual one, lead aluminum phosphate hydroxide hydrate. Some of these mineral combinations are a little bit of a mouthful. This is a Chinese specimen of what's called plumbo-gumite, which is an interesting aluminum phosphate that gives you this sort of very nice dark blue color. Brazilianite is the glassy yellowish crystal, sort of lemon yellow crystal here. It's a sodium aluminum phosphate hydroxide. This is from a well-known area of Minas Gerais, Brazil, which is the state in Brazil, which literally means the general mines. There's so much mineralogy that comes from that region. Brazilianite named after the country, of course, here. Here's an odd one that's an unusual mineral, potassium aluminum phosphate hydroxide hydrate. That's a Chilean specimen called tinsleyite that gives you a very, you just see there's some very basic elements that are involved that are similar in many of these, and different little contaminants are creating these very vivid colors in some of these minerals. This is an Illinois specimen of benstenite, which is a barium calcium magnesium carbonate, also with some gypsum here, whitish gypsum, from a famous region that's really well known for its fluorite, but this is another similar mineral that's in there as well in Illinois. Kyanite is a fairly common and simple, but a pretty mineral. It's an aluminum silicate, this blue stuff, blades of it here. This is another from that area of Brazil that's a fairly chunky specimen with quartz in it as well. And this is that common mineral of barium barite. This is a big piece of it here from the Michael mine in Nevada. That's a famous United States mine for barium minerals. And this is a big piece. It's a sort of a tabletop piece here with these kind of glassy lemon colored crystals. Here's another one that's a little bit different, a sort of a sky blue Colorado barite from another famous barite and barium mineral location up in the mountains in Colorado. Algolite is another unusual aluminum mineral, and it produces some of the recent finds of it from Peru give you these sort of very vivid lime green crystals of this stuff, which is pretty cool with a lot of quartz there as well. This is an unusual mineral. It's an aluminum fluoride mineral, durangite, which is an odd one. It's a fairly small piece here from Utah, and it just shows you that sort of vivid orange red color here. Here's back to barite. This is recently there have been very good finds in China of barite. This is on quartz, but a very vividly colored barite crystals here that are very glassy looking. Here's barite, but from back to Colorado here from another famous mineral town, Gilman, in Colorado here. This is a very odd mineral. It's organic, meaning that it is principally composed of oxygen and hydrogen bonds. Not that it's, extra expensive, fancy strawberries and blueberries in a special case, but organic chemistry means that it's carbon dominant and contains carbon, oxygen, hydrogen bonds. This is melite, and you can see its dipyramidal crystal structure here, and this is an aluminum benzene hexacarboxylate hydrate. So that it's a very long, I'm not putting the formula in here, this would be a long one. But this is a Hungarian specimen and one of a relatively small number of minerals that are so-called truly organic minerals. Sorry, Scott, I didn't mean to, did you say something?
Yeah, I just said that was a mouthful.
Yeah. That's a very unusual, you don't hear that one very often.
No.
Hexacarboxylate, yeah.
I'm going to start using that in conversation. So
I'll try that tomorrow again when I get some more sleep, I hope tonight.
You said it perfectly.
It's a weird one, but you can see in there little crystals that are dipyramidal that formed as the fluid presumably ran out on the surface of the larger crystal too. So you can see these generations of crystals sometimes that form in proximity. And the last one here is just a sort of a stark white barite on hard stone-like mud that comes from, of all places, Muddy Creek, appropriately named Rio Grande County, Colorado. And that just sort of gives you a variety, again, of kind of typical aluminum and barium minerals. And just very quickly, again, Scott and I will pipe in on, we're both going to be involved at Starmus in Armenia in September, which is the international science festival in which we'll have many astronomers, astronauts, you can see them there, and Nobel Prize winning speakers in other allied scientific fields like chemistry and biology. We'll be announcing many, many more speakers over the coming weeks. I already secretly know of some, but we can't quite announce them publicly yet. Our Starmus folks will be doing that soon, and we'll also have some rock and roll and other entertainment there with some of our good friends like Queen's Brian May, Rick Wakeman, and Peter Gabriel and others. So that will be a great, great time. It's actually very easy. If you get to Europe, it's very easy to get to Armenia from there and cheap. So consider that, or maybe you'll see the after effects of all of that later in the fall as well. We hope to have a lot of stuff and exciting things to share with you. And Scott is going to bring over telescopes and put on a gigantic star party for the Starmus attendees. We think there'll be 3,000 to 5,000 people at Starmus and maybe 1,000 people at our star party. So it's going to keep us busy, Scott.
It's going to be busy.
Yeah.
I hate to get bored, so.
Yes,
I-
indeed.
I have a question.
Yes.
David, I was looking through a kind of an interesting list last night called the most valuable substances in the world. And antimatter was at the top of the list at $62.5 trillion per gram.
I like it.
Number 6 on the list at $300,000 per gram was a mineral called painite, a borate crystal.
Oh,
Have you ever run across that anywhere?
I
any
have
chance?
a crystal of painite in my collection, which I paid
$1,000 per gram.
I paid vastly less than $300,000 for my crystal, I can tell you. But I can get the image of my painite and show it next week.
Please.
So I'll make a
Yeah.
note for that. It is a rare mineral, and it's an unusual looking crystal. And it's often accompanied by little, very bright purplish and orange garnets that go along with it. So I'll show it next time, and we'll talk about what it is mineralogically. I'll dig that one out. And it is a rare mineral, and it's somewhat valuable, but I had no idea it was that rare.
Maybe we shouldn't have gone public with the fact that you have it.
There are people now breaking into your
Yeah.
home, David, to get your-
If it's that valuable, let's sell it and we'll go have a party, with the telescopes.
think.
I'll
Right.
figure out what you can do with that 300,000, David. Leave it to me.
Sounds good. Well, thank you, Scott, as always. And at some
Thank you,
point, we'll
David.
work through more minerals, and I'll get back to some more straight astronomy one of these
Oh,
weeks.
yeah, I don't know. I think you're teaching us that the study of minerals and crystals is part of the straight astronomy. So
Well, we have to have something to do during the daytime.
that's right.
Yeah.
That's right. Absolutely. Okay. Well, thank you so much, David. That was awesome. Up next is John Briggs. John is known by many in not only in the amateur astronomy world, but also the professional astronomy world. And he is he's with us tonight, and he will be introducing. I think he's with us tonight. Let me just check here.
Hey, Scott, I'm here, but
Oh,
I
you're on the
activated
VCam. Okay.
my video, and I'm getting something I haven't seen before. That blue comment, can you see that?
I do see it. Yeah.
Yeah.
It's saying that you have a VCam.
What
I'll
is
be
that?
on here with you so that people can actually watch a moving figure. But John, thanks for coming on, and thank you for introducing Dr. Fugate to our audience. And you had mentioned before that you showed some of his images, but through you, I learned that about Dr. Fugate's work in adaptive optics. So maybe you can explain.
Absolutely. Now, I had a few slides I wanted to share, but I don't understand why I'm not sharing my video.
But I think you can share your slides.
Oh,
even though
okay.
You don't have video.
Okay, so I'll share screen, and let's see. Share.
There you
Yay.
go.
Okay, and I'll try to make it big and all this stuff. From beginning. There, okay, can you see that?
Yes.
Very good.
It's
So-
coming up. It's still a all gray box, but
The title is Introducing Dr. Robert Q. Fugate, Founding Director of the United States Air Force Starfire Optical Range. Let's see, your screen sharing is paused. I think I might have to redo this. So I'm going to stop share,
okay.
and I'm going to share screen again. And sorry that I am bad at this.
No problem.
Do you see a picture now?
We do. Yes.
Oh, good, good. Great. Okay. So let's see if I can make it advance from the wilds of New Mexico here. And it did not. It seems that I always have this problem. There, okay. I want to explain how I got acquainted with Dr. Fugate, and it relates to this photograph that I am so proud to have from my own backyard. And Bob Fugate recorded this picture from my backyard. And what happened was I subscribed to the Albuquerque Astronomical Society email list. And one day, a few years ago, there was a message there from a fellow, and it said, well, I'm up here in Albuquerque, and I've done about all I can really accomplish with my current equipment from the bright skies of the city. And I'm looking for a darker site where I can go deeper with my astrophotography. Is there anybody out there who could recommend a site? And it was signed Robert Fugate. I saw that and I thought, holy mackerel, I'm going to reply to this very promptly because I knew who Bob Fugate was. And to explain, I'll continue. But Bob ended up coming to my backyard, and I've shown you some of his pictures before, and I have to admit, when he came, I felt like a kid interested in rock and roll, but having somebody like the Rolling Stones come and practice in my garage. That's how I felt about having astronomer Bob Fugate. But anyway, how it happened that I had that attitude towards Bob was that earlier I had worked at Yerkes Observatory here with the 40-inch refractor. And the very first project that I engaged in was to create a sodium star in the upper atmosphere, as shown here, with a sodium laser shining parallel to the 40-inch refractor. That's in the left-hand side with the refractor pointed towards zenith. The right-hand side here is a CCD image that we recorded through the 40-inch, showing a blob in the upper left. That was actually the so-called sodium star in the upper atmosphere, and the light saber to the lower right was some Rayleigh scattering from the laser beam going way up about 90 kilometers to create that blob. So we were undertaking this experiment in very early 1991 to understand how to make a blob of that like this in the upper atmosphere, given whatever laser power we had available. This was interesting because it was related to this new science of adaptive optics. And the person that I was working with in this small team was a fellow named Walter Wild. And he became a great friend of mine. And within a few years, after our experiment, which was just a small stepping stone in adaptive optics at University of Chicago, this article came out co-authored by Bob Fugate and my friend Walter Wild. It was in Sky and Telescope magazine. Let's see, it was the May issue of '94, Untwinkling the Stars Part 1. And this article, actually it was a series of articles in over 2 issues in Sky and Telescope that involved 19 editorial pages to cover this topic when it finally came out. It was a big splash, and Bob Fugate was the first author. And further, part of this splash was a biographical article about Bob with text and photographs by the famous and excellent photographer Roger Resmeyer. And I just am encouraging people who want to learn more about the revolutionary topic of adaptive optics to look back to these articles in Sky and Telescope back in 1994. They are great. And but perhaps the coolest thing was how in the first of the 2 issues, there's Bob Fugate on the cover, beside the gigantic telescope we do in fact have here now, right at the Air Force Base outside of Albuquerque, New Mexico. Adaptive optics straightening starlight. But how it began Bob had smaller telescopes, 1.5 meter telescope here projecting a bright laser beam and early experiments related to all this. I'm going to let him explain some of the details for you, but Roger's photographs are just so spectacular. I could not resist reproducing some of them from these magazine articles. But the quotation from Fugate, who is with us now, is, let me just read it. In the movie Jaws, there's a scene with two guys in a boat. The shark comes up out of the water and he's wider than their boat, Fugate recalls. One man turns to the other and says, "We're gonna need a bigger boat." And that's how I felt in 1987 when I went into Director Pete Avanos's office and said, "Sir, we're gonna need a bigger telescope." And he threw me out on my ear, but I just kept going back, unquote. Persistence, hard work, and the 1.5 meters results paid off for Fugate, and the Air Force eventually approved the 3.5 meter project, and here it is. And Bob will have to tell us, is that actually he climbing the ladder there on the left-hand side for some human scale on this amazing telescope that is here in New Mexico, doing quite fantastic things. The article that I'm referring to is a great reference to learning more about the technicalities of AO. And there's also a book that's been published, The Adaptive Optics Revolution, A History. This technology truly is, folks, a revolution for ground-based astronomy. And it was written by this Air Force historian, Robert Duffner. Now, as nice as the title page is, it's actually the dust cover of the book that I think is especially cool. There it is again, Adaptive Optics Revolution, A History. Who's on the cover? Bob Fugate, as a young man with, I presume, his first telescope. And Bob, you're going to have to tell us, is that a little Criterion reflector? Looks like a 3-inch Criterion reflector to me. So there's a very hasty introduction to Bob Fugate, who I'm so grateful to call a friend here in New Mexico. So I'm going to stifle myself, and I hope that Bob can take over and continue the discussion.
Okay, can everybody hear me?
Yes, let's.
Yes.
Okay.
On the screen here.
Well, gee whiz. John is always really good at embarrassing people, especially me.
Yes.
So I don't know. This is a hard act to follow. Let me try. Let me see if I can share my screen here and get the presentation started. And I wanted to give first of all, that was in fact me on the telescope. And what else did you ask? Yeah, that was a 3.5-inch refractor. I think the very one that was shown earlier in a catalog. So it's a small world. Any rate, I have a lot of material here, too much. I'll see if I can get through it. This is just a collage of how laser guide star adaptive optics has evolved and over the years. And let me see if I can hide this. So it all started in when we did the very first experiment in 1983, and I'll talk a little bit more about that. And that moved to a 1.5 meter telescope, as John mentioned, and then to the 3.5 meter. And these first two experiments were done with Rayleigh guide stars, created by Rayleigh scattering in the air. And hang on just a sec. And so it's evolved, and it's actually become the enabling technology that makes these very large telescopes practical and feasible. And so we expect with the extremely large telescopes coming up in this coming decade that this will be a very important, if not essential, ingredient in the operation. So let me tell you how this really happened and came about. So I started working for the Air Force in 1970, and it was the height of the Cold War. The Soviet Union were launching satellites every 2 or 3 days. The US was desperate to know what they were about. A lot of them had military applications. And so the Air Force built a telescope in Cloudcroft, New Mexico, a 48-inch. And the observer, if you can see here, actually rode on the telescope. And you know, they were counting on the eye-brain neural network to help the distortion caused by turbulence. But mostly what they got was a lot of blurry images. And why was that? So I'm going to give a quick explanation. If you have a telescope in space and it has perfect optics, you have essentially a diffraction limited telescope. Here's an example of the trapezium imaged by Hubble. But if you're on the ground, here comes your nice plane wave traveling through the vacuum of space for 12 billion years. And in the last millisecond of its journey, it has to go through the atmosphere and gets totally screwed up phase-wise. So it becomes a crinkled mess and you get this blob. And now the resolution of your telescope is limited by the atmosphere, and in particular by a parameter called R0, the Freed parameter. And that's typically at a really good site, 15 or 20 centimeters. So if you have a telescope that's bigger than that, you don't get any bigger resolution. You get the same blurry image that you get in a smaller telescope. You just get that blurry image faster. But what if we had a magic mirror? And by that, I mean, what if I knew what the instantaneous distortion of the wavefront was, and I could put that shape or actually its conjugate or the inverse of that on the surface of the mirror almost instantaneously, so that when the distorted wavefront reflects off the mirror, that distortion gets removed. And I'm back to my plane wave that I had when I entered the atmosphere. Well, this is the basis of adaptive optics, and it was originally suggested by an astronomer, Horace Babcock, in 1954, but it wasn't until 20 years later that we had enough technology to actually implement it. And so we put our magic mirror behind the, in the reduced optical space of the telescope, and we sample part of the wavefront with a sensor, shown as item number 2 here, and that runs up and controls the surface of our deformable mirror, this magic mirror that we're talking about. And so the first of these in operation, at least for anything real, was built under the sponsorship of what was ARPA at the time, now DARPA, by the company ITAC, installed on the 1.6 meter telescope on Maui. And it was a tour de force. I mean, it was still very difficult piece of equipment. This is a big operation. I don't know if my cursor shows very well, but here is, take a look at the size of a person standing on the floor of the observatory here. The problem with this instrument was, yes, it worked on bright targets, but it didn't work on fainter targets. And a lot of the satellites that the Air Force was interested in looking at were pretty faint. So one of the people sort of involved with the project, Julius Feinleib, was standing on the ground one night and he noticed the LIDAR going out to measure atmospheric transmittance. And he got the idea that maybe you could use a laser to create a beacon that could be sensed for the turbulence independent of the target. So you would use the laser to, do atmospheric wavefront sensing, and then you could integrate as long as you needed on a faint target. So he actually called a meeting in the fall of 1981. I was at the meeting, And David Fried, the kind of the free world's expert on turbulence, was there. And initially he said it wouldn't work because it was too low, not measuring enough. But he did some analysis, and what he determined was the idea would work, but only for small apertures. It needed to be higher. And it was going to be too difficult. The air gets too thin for Rayleigh scattering for that to work. Well, by chance, the group called the Jasons asked to review this project. They got word of it. And so in the early summer of 1982, Will Happer from Princeton chaired a committee. It had people on it like Freeman Dyson. So I and David Fried went to brief these folks. And Will Happer said, so your problem is you can't get the beacon high enough. And David Fried said, yes. And Will said, well, why don't you resonantly excite mesospheric sodium? It's at 90 kilometers. So David and I looked at each other. We didn't know what the hell he was talking about. But, you know, that's how we now had. And so it turns out there's this layer of sodium atoms that are about 90 kilometers above the surface of the Earth that are deposited by micrometeors. And sodium is light. The meteor burns up. The sodium is light. It sort of hangs out. It has nothing else to react with. So now we had two concepts. One that used Rayleigh scattering, shown on the left, and the idea being that, you know, this could only go to a certain altitude, maybe 15 or 20 kilometers because of the air density. On the right, though, we could get up to 90 kilometers if we could excite these sodium atoms. So we had the two concepts, and DARPA immediately classified the concepts. And they also sponsored two experiments. And the objectives of the experiments were, you know, they wanted an experiment for each concept. Could you sense turbulence with backscattered laser light? Was that even possible? And the second was, do these results agree with Fried's theory? He had a theory about the fact that the beacon is only at a finite altitude and not at infinity. So if you're using it to measure light that comes down in a cone instead of a cylinder, you're going to make an error. And we called that focus anisoplanetism. And he had a theory about how well it would work. So I immediately volunteered to do the Rayleigh experiment because I had no idea how I was going to build a sodium laser that was powerful enough to work. And Lincoln Laboratory, MIT Lincoln Laboratory, unfortunately got stuck with a harder experiment, and it took them an extra year or a year and a half to get the results. So here's the only picture, because this whole concept was classified and limited access, and there were probably 50 people in the country knew we were doing this. The idea was that we pointed a pulsed laser at Falieres. We didn't have a gimbaled telescope. We only had a gimbaled flat. And the idea was to compare the light backscattered from the laser in a range gate, only at a certain range, with the light coming from Falieres. And all of the setup, and we had sort of a Shack-Hartman arrangement made out of Risley prisms and a 40 centimeter off-axis parabola on the bench to make a telescope. And so here's a couple of the measurements. Here's on the left, you see a wavefront reconstructed from Falieres, and on the right, a wavefront reconstructed from the laser. And in the middle at the top, you see the difference. And the question was, does that agree with Fried's theory? And here's a plot showing two sets of experimental data and the dashed line being Fried's theory. So this was an incredibly important chart because it basically verified that we understood the theory about how this would work. And later, Lincoln Laboratory did the experiment with a sodium laser and demonstrated even further how it depended on range. We demonstrated how it depended on aperture diameter, and they demonstrated the range part. So eventually this technology, this was 1983, and in 1991, 8 years later, it was declassified, mostly because of the demise of the Soviet Union. And we immediately published the results in Nature. And that even created some humor by the editors of Nature. And if you know anything about Nature, you know they're not very jovial. They're serious, dead serious all the time. And so they published a little editorial in the issue where this article was published, and it was entitled "Beam Me Up, Scotty." So this is a picture of the 1.5 meter, which we got a copper vapor laser installed on. So it ran at a high enough rep rate that we could close a loop continuously with a real deformable mirror. The initial experiment was all open loop measurements. And so we were able to do initially some science with that setup. And one of the first things we looked at was the trapezium. And we looked at it with a H-alpha filter and a continuum filter. And so here you can see the difference. And this shows the formation of these polypropylids, new stars forming that are not yet emitting in the continuum. So we offered the telescope to the National Science Foundation, and we had a regular parade of astronomers coming through using the system. But while this was going on, John's quote there was perfect, because I went into Pete Avazonas the day after we installed the 1.5 meter telescope and said, we're going to need a bigger telescope. And that's when I got thrown out. But we kept going back, and eventually we built a 3.5 meter, and it was based on spun cast borosilicate mirrors by Roger Angel at the University of Arizona. And that telescope got installed in the early 1990s. And we even had a collapsing dome, because we were mostly interested in tracking satellites, and they go over fast, and the telescope has to go around fast, and we couldn't move a dome with a slit. So we decided just not to have a slit, and we just lowered the dome, and it's worked out incredibly well. So we got the adaptive optics working by 1997. Our budget had been slashed a lot in the 90s, but we finally got through it. And by February of 98, we had it tuned up pretty well. Here's an example image. This is a 0.098 arc-second separation binary star, and having a Strehl ratio of about 1/2 at 0.8 microns.
Man, oh man.
And a comparison of the open loop and closed loop image. So it was very successful in looking at satellites, and but it wasn't until 2004 that we had solved the problem of how to build a sodium guide star that was practical. The problem is sodium vapor can't laze. It has too short of a lifetime. You can never get a population inversion going in a vapor. And so it turns out that our first laser was built by mixing in a nonlinear crystal the 2 IR wavelengths, the strongest lines of neodymium YAG, 1064 and 1319. And that comes out perfectly at 0.589. And so that's what we used to build the guide star. And it was all done in-house at the Air Force Research Lab. So it's been used to look at faint objects. One of the things the Air Force is always interested in is looking at geosynchronous satellites and making sure that high-value assets aren't being approached by nefarious objects. And so you have the problem of a bright object, relatively speaking, and a very faint object. And so one of the things that we've looked at are asteroid moons. And here's an example. We also still have the 1.5 meter, and now we have a modern solid state frequency double YAG laser on this telescope. And here's a picture. it almost looks, here's looking down the throat, if you will. The 3.5 is on the right, and on the left is a seeing monitor that is used to measure the seeing. This almost looks like a graphical package produced, but it is a real photograph. And we have at Maui now, at Amos, where that very first system operated, there is a 3.6 meter telescope. And, you know, they beat us out by 1/10 of a meter so they can claim the rights of having the biggest Air Force telescope, or the biggest telescope in DOD, I guess. And so they have a guide star on that system as well. And in the middle of the picture, in the background here, you see the NOAA Solar Telescope there on Maui. So today, all large astronomical telescopes have laser guide stars. And in fact, people don't even think about, you know, all the new extremely large telescopes basically have adaptive optics laser guide stars built into their design. And this is the 8 meter, one of the 8 meter VLT telescopes in Chile. And the astronomers have advanced this art quite a lot, and using multiple guide stars and multiple deformable mirrors in order to increase the corrected field. Normally you're limited by the isoplanatic angle, but if you use a asterism of guide stars and multiple mirrors, this picture at Gemini South, for instance, where they have 5 laser guide stars, has a 2 arc minute field and is well corrected over that whole field.
Oh, yeah.
So let's see what's happened here. I'm going the wrong way. Oh. So where this is leading, of course, is the new telescopes, the 2 biggest being the 30 meter and the 39 meter telescope being built now. And of course, there is still some contention about the 30 meter telescope on Mauna Kea, but we're hoping that gets worked out. And they're working away on the 39 meter European extremely large telescope in Chile. So I'm 17 minutes in. Let me see if I can tell you a little bit about, if I'm getting too long, just cut me off. I'm going to switch to now the famous Fugate Observatory, which is in the backyard of my house in Albuquerque, New Mexico. And the thing that makes this famous is the mount is on loan from John Briggs.
Ah,
So I would not be where I am today without it. And, it's really, I'm seriously indebted to John, because one of the things I've figured out is by using short exposures, I can run this telescope unguided, even on narrowband images, and get 95% of my signal to noise in a shorter exposure. So I just really like the idea of not having to fiddle with a guider. I show one on the telescope here, but it's rarely used. So just let me, you know, the imaging strategies I'm using are not new. They're not revolutionary. They're common. And in fact, I'm a little embarrassed to be showing any images here because they're ordinary. And but let me just tell you a little bit about my strategy. And that is, if I'm looking at broadband targets, and I do that, it just takes a lot longer. And I'll kind of show you why. To reduce the shot noise associated with the sky. Your choices are a monochrome camera with broadband filters, a one-shot color camera, but in either of those cases, you have to average a very large number of images to get to where you would be if you were at a dark site. On the other hand, in narrowband, a mono camera with narrowband filters as narrow as you can afford, and I'm using 3 nanometer filters. that's a really good choice. And now of recent, we have a technology that we've actually been using that I used in the Air Force a long time ago, and that is specially made filters that have multiple lines that are narrow. So you can get duo or trio or even quad line filters now that you can use with a one-shot color camera. So you can take advantage of the Bayer filter pattern in the camera and the filters all at once, and you're not being inefficient by using a single line narrowband filter with the one-shot color camera. And quite often, if you're doing this, you'd want to capture separately RGB stars. Stars are bright compared to the sky. So you can do, short exposures, 30 seconds or less, and get star colors and then add those in. Take out the monochrome stars and put in the RGB stars. And then, of course, it still helps to average lots of images. So the one thing I've done is tried to be quantitative. And here I show a plot of, on the left is the photo detected electrons per minute per pixel for my setup with the Takahashi 106 and the ZWO ASI 6200 monochrome camera as a function of sky brightness in magnitudes per square arc second. And I have a little sky quality meter, which I carry around with me mostly everywhere that I go, which isn't very many places these days, and keep track of what the sky is like. And one is easily able to convert the sky brightness measurement into what kind of signal, what kind of mean signal you have on a particular setup. And in this case, it's mine. So here at home, I get about 100 photo-detected electrons per minute per pixel for a G-band filter for a 1 minute exposure. Well, this is per minute. So if I go to the Gila, and I have some friends that have property there where it really is dark, I get about 10 electrons. Here in Albuquerque, I get like 100. So what that means is if I were to sample the pixel values in an image, like do a horizontal scan through the image, I get these kind of results. The bottom down here is a dark frame, but then in the Gila at an SQM of 21.95,
Nice.
you can see the noise level. Here in Albuquerque, the noise level is quite a lot higher. And if the moon is out, even in Albuquerque, it makes a big difference. So our problem here is all this noise. If we're looking for something that has a small signal value in a single exposure, you're not going to be able to get that. So that's why, of course, we have to average in order to, if there is a gradient on this image, and let me show you an example. Here is the Witch Head Nebula. This is an average of 100 1-minute frames, and it shows quite clearly the gradient of light pollution. And this blue line is a sample through the image, which is displayed over here. For instance, this little bump here, I don't know if you can see this, but on the right side, this little bump is the witch's chin. And if I look down at this lower one here at the bottom, here I've removed the gradient, but I've also compared it to a single frame. And this is an L filter, not a, one of the color filters. So it is a wider spectrum. The noise is enormous. Can I see anything else in there? Not really. And what I've done between these two is I've removed the gradient, but the important point is I haven't removed the noise. So I still have this fuzz, this what's ever left over from averaging 100 frames of the shot noise. When I subtract the DC gradient, I still have that shot noise. So the only way to get rid of that is to average more and more frames. So this, of course, brings up the question, what is the optimum exposure time? I keep clicking the wrong button here, sorry. And it really depends upon, it starts to depend upon how bright the sky is, how bright the target is, and how much read noise you have. and also how much dark current you have, if that's significant, although these days it's, for a cooled astronomical camera, it's not very significant. So this just shows typical read noise values for CMOS cameras, the new modern CMOS low noise cameras compared to CCD cameras. And it shows a slight advantage to the CMOS for achieving, the ultimate signal to noise in a short sub-exposure time. And, as you get to a darker site, if I were to look at this plot, for instance, for the Gila, this would be much more pronounced. I would need much longer exposures at a dark site. So you could say one of the advantages of living in a bright sky is you can do shorter exposures. You got to look at the bright side of things, right?
Right.
So then let's talk about narrowband quickly. Here's two exposures of 1 minute each of the Flaming Star Nebula. The one on the left is a red filter of 100 nanometers bandwidth. The one on the right is an H-alpha filter of 3 nanometers. And so clearly we see the advantage of going narrow band in light pollution because it's greatly increased the contrast by simply reducing the background. And if I sample these two images along these lines, I get this. So the black dots are the R filter and the red dots are the narrowband 3 nanometer filter. And here I've estimated the noise just as the square root of the mean signal, again, assuming Poisson statistics for the random arrival of photons. I didn't say it, but this is a spatial sample of pixels, which is for these kinds of detectors where there is such uniformity pixel to pixel, it's equivalent to doing a temporal average of 1 pixel over a lot of samples. So you can still see a little bit of a kind of a gradient, and you can still see the presence of a signal even in a single frame here. But the signal to noise down here is much higher. So the other aspect, and at least half of what you get in an astro image, is the processing. So I've been using PixInsight for some time and Lightroom. And I think, what you do in the processing is a whole big super topic. And I think following me, we're going to have some people that know a lot more about it than I do. But one of the things I do in Lightroom that I've found, and if there's any secret sauce to any of my imagery, it's using luminosity masks in Photoshop to enhance the contrast of various parts of the image based on their luminosity. And so I can bring up the stuff that's weak and compared to what's bright and not affect that. So let me just show you some images. I'm already out of time. This is the Boogeyman Nebula, Barnard's Loop, and M78. I think everybody probably recognizes. This was 14.98 hours, and this is a broadband image. So if you integrate long enough in the city, you can get pretty good results. Here's another classic, and this was only 4.42 hours, and it does have some H-alpha enhanced red channel. Here is the Witch Head Nebula, that we were looking at earlier, and this was 3.67 hours over 2 nights. Here's my last fall's Andromeda. Again, these broadband targets are bright, and it's going to be hard to do things other than that. This was actually 10.3 hours over 3 nights. Here's the Iris Nebula. I just love this target. This thing is really cool. And you can see lots of dark nebula here. And this was 18 hours over 5 nights, and it's 2 panels. And here's the classic M81 and M82. And you can even see some integrated flux nebula in the city of Albuquerque in a broadband image here. So it's pretty good. And 11.48 hours. Here's Orion, and this is just such an incredible target. This is a lot of different exposures. I should have left all the details on, but it's a high dynamic range kind of construction, and it's only 2.6 hours though, because it's so bright. For narrowband targets, here's the Cygnus loop. This is a modified SHO, and 20.3 hours of total integration. Here's the Pelican Nebula. This is highly cropped out of the frame in only 1 hour. Here's the inside part of the Sol Nebula, and it's 5 hours. Here's the inside of the Heart, 5 hours again over 3 nights. And the nice thing about narrowband is you kind of have an artistic license to modify colors to make them, kind of a work of art if you're so inclined. This is LBN 581 and NGC 7822. Here's my meager attempt at Thor's helmet. And here is the elephant trunk with the stars removed. I kind of like it this way because it really shows a lot of structure in the clouds. 7 hours of integration. And I really like to do single line monochrome images because it really gives you lots and lots of interesting structure. And here's only 2.08 hours on the Horsehead. And this is M42, but it's with a sulfur only filter. And by the way, this is a single 20-minute image. I did use tracking on this one, but it's a single 20-minute image. And of course, Orion's right in the middle of the geobelt. So in one image, I had no way to get rid of the satellite trails here. It's amazing that you can see geosatellites through a 3 nanometer filter. But you get to see all of these shock fronts and stuff. And I want to do more work on sulfur around this region. And here's a 3-panel H alpha mosaic, 4.5 hours, 1 night. And I dug up real quick Omega Centauri, since it was the topic earlier. And this was made from the Albuquerque Astronomical Society's observatory, the General Nathan Twining Observatory south of Albuquerque. And here is Omega Centauri in all its glory in the New Mexico desert. Here's another New Mexico desert shot of Comet Neowise. And it just so happened that this T-Rex was running for his life at the time. So sort of a Cretaceous extinction shot. Okay, so that's all I had. I'm sorry I kind of ran over, but that's what I had to show.
Actually, Bob, you landed almost exactly on the right time, because the next speaker comes up at 7:30 Central. So you guys were in combination doing pretty well. That's great.
That was a great presentation.
Yeah,
I like that.
I want to add to my enthusiasm about that I might have expressed earlier, Bob, in my emails to you. But we are really honored to have you on this program. So.
Well, I'm really honored that you asked, and so thank you very much for the opportunity.
Thank you so much. That's great.
Hey, Scott.
Yeah.
Can I just ask Bob a question real quick?
Please do. Please do.
Yeah, I was just wondering, Bob, it's Shawn Nielsen here from Visible Dark.
Yeah, hi, Shawn.
Hi. I was just wondering, your exposure time, is it typical that you're doing 1 minute? Is that
Yes.
the short exposure? Okay. And
Yes.
what gain and offset are you using for the camera?
I'm using the standard one. I'm using a gain of 100 and an offset of 50.
Okay. All right. Fair enough. That's good. You got some fantastic images, some great results, very, very high details in it.
Yeah, I have, I skipped over a lot of stuff there, but, if you don't have to guide, first of all, you have to do the periodic error correction on the mount, and you have to do the polar alignment well, but the Paramount ME and software, I run the whole thing on a Raspberry Pi, and I run it from my office over a 150-foot Ethernet cable that just lays on the ground. And I have a Linux workstation inside that runs K-stars and Ecos, and I run that as a server on the Raspberry Pi, which also runs the SkyX, which is absolutely required to run the mount. But it turns out that the Raspberry Pi actually runs the SkyX. You can run the full deal on the Raspberry Pi. So, and I download 128 megabyte files in a little over 2 seconds and I get them in real time on my display and on my workstation, and they go on a NAS server, and I can also look at them in detail on another computer in PixInsight while the observation's going on. So I can keep track of whatever I need to. But with the good polar alignment with T-point that's available in the SkyX, I make a mount model and get a good polar alignment. And with the periodic error correction curve installed in the firmware, I don't have to do any guiding the drift rate is about 1/10 of an arc second per minute. So in 10 minutes, it drifts 1 arc second, which is way less than the seeing.
Right. Yeah. No, you have some fabulous images. The details
Thank you.
Are just incredible. So
I feel honored talking to a famous guy like you, Shawn.
Famous guy. No, that's Dan.
No, that's not me, man. No, that's.
Well, you're both famous.
No, not even close, man. Not even close. I made my first $4 on YouTube, I think, the other day. So
I can't charge William Shatner prices for my autograph, so I'm not famous.
Oh well, I gotta say, but do you have a William Shatner autograph?
Oh, Dan, you're killing me here. I got 2 of his autographs. I got one on a action figure and one on a picture.
So do I. I have 2 too.
Oh, Dan, that's a great one. That's a good one.
Yeah,
that's fabulous. But
I was lucky to meet him on the 50th anniversary.
Right? Yeah, that's awesome. That's great. Well, that was a great presentation, Bob. Really enjoyed that. Thanks for doing
awesome pics, man. Those things are great, man. What size scope was that again that you were doing?
It's a Takahashi FSQ 106, so it's a 106.
Wow, that's awesome. You got some great stuff, man. Thank you.
And thank you.
Hopefully you don't have to give John back his mount. Yeah,
I don't know what I'm going to do if I do.
No, I'm not. It's being way too productively exploited. It's really. I'm a reflection nebula, shining in Bob's accomplishments. So it's really great to see what he can accomplish right from the city. This can't be overemphasized. That so many of the images he shared were recorded in Albuquerque. What's the population in Albuquerque, Bob?
I don't know. It's 350,000 or 500,000. I don't know. I haven't kept track.
Yeah, well,
it's probably 500,000 in the area here. In this,
it's an amazing thing. It's wonderful.
All right, thanks again, guys, for the opportunity.
Thank you, Bob. I hope that we can get you back on to one of our programs. I think that we could probably do just a program just on you with all your experience and everything. I think that our audience would find it fascinating. So I'll hit you up for that sometime.
All right.
Thank you. Thank you very much. Thank you too, John. All right. So, Dan and Shawn, it's the Dan and Shawn show.
Dan and Shawn show.
We're tag
we just need some beers.
You don't have some?
Man, no. You know what? I'll make sure. I'll make sure I make believe he can't see me. Hold on a second.
Oh no! Oh, Dan, where did Dan go? Oh, there he is. There's Dan.
How's it going,
awesome.
Shawn?
It's going great, Dan. Good.
It's awesome to be on the show with you, man. Again, we've been on each other's shows over the past
we have
year or two.
Absolutely. Yeah,
and a lot of fun.
Yeah, we sort of just bounce things back and forth with each other from show to show.
Absolutely, it's great.
It is, it's really good. I enjoy the Astroworld show. I try to tune in as much as I can, and you got a great thing going there, Dan. Yeah, really good job.
And you as well, man. I mean, I've been watching you for years. So I mean, we only started, I guess, we started about 2 years ago in earnest, like 2 years ago, and we were on like 4 years ago. Me and Charlie Walsh, and he was like Cosmic Charlie and Declamation Dan.
I remember. I had said I saw the one episode where you guys were in a kitchen talking about an eagle, if I'm not mistaken.
Yep. Yeah, we were doing an eagle, and then we were in a basement with a blue couch doing something. I think we were talking. Awesome. I think we were talking to Chuck Ayub one day on the cell phone. We had the cell phone on the table, and we were like, he was on speakerphone because you didn't have any of his stuff set up yet. This is before, before he exploded. But
that's awesome.
Yeah. So, but you got some great stuff with the Pix Insight tutorials and your beginners tutorials. I still watch. I bought it. I watch it, and I continue to watch it because I always pick up something new every time.
Yeah. Well, that's the thing, right? I like to sort of see what other astrophotographers are doing, how they're processing their images, because you can pick up little nuggets of information, little techniques, tricks, things like that you may not be aware of. So for me, it's about sharing the knowledge that I've accumulated with regards to image processing. But I really enjoy watching other astrophotographers like Bob. I would love to get Bob there back demonstrating his luminance technique there for inside Photoshop and Lightroom and that he uses to bring out details, the fainter details in that. It would be really interesting to see how he does that. Little nuggets of information like that are fantastic.
Yeah, absolutely. Because it's everybody knows that that does the processing of imaging. It's so subtle. And the things that you do are so little, basically if you see it, you see it, you did too much. And it's like one of those things that I picked up from you on your YouTube channel. And if you're blowing it out, you're blowing it out. Okay, go back and do it again, because you can watch the video over and over and over again. And it's really, I mean, Visible Dark in itself, your website and your channel is just helped me out personally immensely. I know I talk to you over Messenger all the time.
Yeah.
Like, hey man, what's up with this QHY camera? I'm from the US. I don't know what QHY means. It's different. It's a different type of different type of camera than what I'm used to. I started with an S-Big. Well, my first real camera was an S-Big. I went to I kind of went to ZWO, and then I kind of veered away. I went to QHY route. So and I'm loving it. I actually tonight I'm going to be getting first light with the QHY 268. It's all set up, ready to go. Nice. Yeah, the monochrome. Yeah,
that's great.
It's basically the same thing you got set up in your back right now.
Yeah, it's almost identical. Yeah, because we've both got Explorer Scientific 127 set up, and we'll have the QHY 268M connected. Yeah, so almost identical setup. So it'll be interesting to see what results you get using yours. You've got worse light pollution than I do, that's for sure. But
that's why I'm shooting 8K tonight. So
Yeah, well, HA is great. Yeah, definitely. If you're in the city and that, and you got light pollution problems, narrowband is the way to go. I really only get about an 18 or 19 on the SQM meter here, which is, we're in a population of about 500,000 where I am in the city. So it's not huge, but it's enough that it certainly impacts the skies and the quality of the sky. So. But you got to work with what you got, you know.
So right now, with the eagle eye, I am at according to the eagle eye pointing in the north.
Yeah.
I'm at a 17.21. So,
wow.
so
just pack it in and take up Xbox.
And that's why, I mean, that's why I do a lot of narrowband, and you know, because right now we got what I guess about a 75 to 80% moon up right now.
And
you know, so, but I also have the Red Cat set up. I'm going to be testing that with the iAxis 100 mount tonight.
Yep.
And I got like this M81, 82 project that we're going to be doing, but
that's awesome. Yeah. Well, you've gotten some, you've gotten some really good results with, you know, considering your situation there and the light pollution that you're dealing with. So fantastic stuff that I've seen.
That's one of mine.
I can see that behind you. That's great. Yeah, that's really good. Yeah, that's awesome.
That was with some help from a friend.
Is there? Okay.
Yeah, so got some processing help there.
Was that Ron?
Yeah, it was Ron.
Yeah.
But you know, I was like, I need to get this gradient out of here, man. It's crazy because I'm doing RGB and Bortle 8+ skies. It's just horrible.
Yeah, it is. Yeah. Well, what do you in PixInsight? Were you using dynamic background extraction normally for your gradient removal?
Yeah, I only use dynamic. I don't use.
That's all I use now too. I know a lot of people like the automatic, but I find the dynamic background extraction works a lot better in a lot of cases.
I think a lot of people are scared about it, though. I think that,
they don't know how to use it necessarily.
Yeah.
Which is why I actually put out a video about how to use it, a little in depth, probably a little long for most people, but there's really no way to explain it any in less time, basically. No. You know, but once you pick it up, once you learn how to do dynamic background extraction in PixInsight, it isn't that difficult to do actually. So you can do it pretty quick.
The one thing I should probably tell everybody about dynamic background. One of the things that people overlook a lot is the background map, and they just say, I don't need that, and just go and place blocks all over the place, and you're really going to do a lot more damage to your photo than what you would really want. And you just take a look at that, super stretch it, see what it looks like. And if you're doing one-shot color and you still see a little bit green in this area or a little bit blue in this area, put another sample somewhere. You know, maybe you have to do a diagonal or a radial or a horizontal or vertical, and because if you're dealing with nebula, you got to get that area. You know.
Yeah, exactly. Yeah, exactly. So, what do you got coming up on the show, Astroworld?
Oh, what do I got? I just picked up, and I'm going to say it, Max. I'm sorry, I'm going to say it. So Max, who's on this show all the time, is going to be a guest in May.
Oh,
so he's going to be coming in May. And Adrian, what are you smiling for? You're next. So
I'm putting together how I'm going to follow up all of these excellent images with the stuff that I've got, because lately I've probably done a little more birding than I have night photography, thanks to our cloud cover. But I've got a couple things brewing that I think is going to work. So we'll see how it goes. I'm collecting a couple of images right now, and I'm going to try and put a slant on it that's going to make it in the theme of the starscapes that I usually share. So we'll see how this works.
Nice.
So I know Scott loves loves birding. So I've begun mixing in some of my birding to the show, and
it's all part of the universe.
Kind of an irreverent after showing night photos, I end up showing a little bit of the birding that I also do. And I'm going to kind of combine the two this time.
There you go. You have
So
birds
we'll
in
see how that
space.
works. Well, there won't be birds in space. They'll be,
Well, they
they'll
are
be
in
within
space.
our atmosphere, probably close to the ground.
All right, cool.
But closer to the ground than us. But so is it my turn to go, or you have you have other?
Well, if I could just really quickly
go ahead
just go
and
over the
keep
guest
going.
list that we got. So this Wednesday, I think it is. It's like tomorrow. It's tomorrow. We have Charles Bracken coming on. He's an author. He did. I'm sure a lot of people know the Deep Sky Imaging Primer. He just came out with the Deep Sky Planner, the second edition. He's actually going to be going over. He put the presentation together of 17 steps of how to improve your astrophotos. So you may want to check that out. After that, we got April 29th, we got Dr. Gaston Baudat, if I might have messed that up, from Innovations Foresight. And he's going to be going over, I guess, a less known way of guiding, known as on-axis guiding. And he's going to be going over what he has at Innovations Foresight. Then we got on May 4th, we got Richard Wright from Starstone Software, formerly of Software Bisque. And on May 13th, we have Eric Coles, who's an astrophotographer as well, and one of the main guys over at the Astro Imaging channel. And he's going to be coming down and hanging out with us there. So nice. and then we got Maxi going to come on the 20th of May. He couldn't fit the thing, but he's going to be on the 20th and showing us a lot of photos. And we'll talk about, we haven't even spoke about what we're going to be going over yet, but we will.
That's great. That's good. That's a nice lineup. That's a nice lineup of guests. Way to go. Do you mind if I just, Scott, show a couple images real quick?
Hey, absolutely.
Okay, let me just
You
show
can't have an
you.
astrophotographer come on and not show astrophotographs.
Yeah, no doubt, eh?
Right? Hey?
Can you see my screen there?
Yep.
Yes.
Okay, so I just wanted to show a couple images. First of all, this is the setup that I'm using right now, and I'm really, really impressed with the Explore Scientific, the 127. This is the carbon fiber edition. It's been working really fabulous. I've been getting some really good results with it. So there's the 127. I've got my auto guider underneath. And I've got, we won't mention this other telescope here. We'll just ignore that one.
No, you can mention it. That's cool.
Is it? Okay.
Absolutely.
Wasn't quite sure.
Hey, Explore Scientific does underwrite these shows, but it's not the Explore Scientific show. So
right, yeah. Well, that's a William Optic 71 that I have there, and I use that primarily for one-shot color work, just because then I don't have to take cameras off the main scope and switch things out. So I use that. It piggybacks on top, and I don't use it all that much. It's really just extra weight, but I do use it sometimes. So primarily I'm using the Explore Scientific right now. But this is one image that I took of NGC 2264 that turned out really nice, I think, using the Explore Scientific 127. And this is all shot from Bortle. On average, I'm about a Bortle 7. It depends what direction I'm facing. If I'm looking more towards the city core, I would be Bortle 8. If I'm looking away from it, I'd be into Bortle 6 maybe. But on average, I'm about Bortle 7 sky. So this is an LRGB with H alpha image that I took of NGC 2264. And this one here, I'm really happy with, actually, NGC 1333. Again, this was shot from, fairly light polluted area, and it is not using any narrowband. This is all LRGB, heavy on the luminance. A lot of luminance data went into this. I can't remember. I think there's about 14 hours of data for this image, and the majority of it is luminance. The color data is only about maybe 3 hours of that. But it turned out really well, and it captured a lot of the dark dust and so forth, and a lot of great detail and colors within the nebula region, the reflection nebula and the mission nebulas and whatnot. So really happy with that image and the quality of both the telescope and also the camera. The QHY 268M has been a really great camera. I've had a really good success using it. So. And then just to end it out, this is just to go back in time. This is me way back in the day. Yeah. Check out the hair.
Rock and roll, man. Hey,
Yeah.
flock of seagulls. You know why we're here?
This is actually one of the first telescopes that I had, and it was an 8-inch Newtonian, and my dad and myself, we actually built it. We bought the components and put it together, and it's not what started my journey in astronomy, but it was part of that journey, and I wish I still had it, but I don't anymore. I actually don't know what happened to it. I was out of the hobby for a little bit before I got back into it, so a lot of the older telescopes and that I had, I don't have anymore. So that's, but I just thought I'd show a couple images anyways for you guys.
Very nice.
That's awesome.
Check it out and sort of brag about that 127 a little bit. You know?
Yeah, hopefully I'll have something to brag about next week. So, you know,
I look forward to seeing the results that you get, Dan. That'd be awesome.
It's gonna be pretty cool. But yeah, so it's been a great night. So just that's all I got.
It's great.
Yep.
And
Awesome.
before you two guys go, Daniel, I've posted astroworldweb.com that people can go and visit. Shawn, you teach people how to image process, and
I do. Yep, they can.
And stuff.
Yeah, they can go to visibledark.ca. That's my website, and there's information there. I've produced 2 tutorials for PixInsight to help beginners get started in it, and I also do one-on-one tutoring with individuals as well that you can hire me basically to help you navigate your data and learn how to process one-on-one.
Great. Yeah. What better way to learn it? So it's awesome.
Yeah, absolutely.
That's awesome. Okay, guys, thank you so much.
Thanks for having me.
Hope to have you on next week's program. The theme next year, or not next year, but next week, will be stellar streams. So, you know, there are streams of stars that flow through galaxies, and but there's other meanings to stellar streams as well. So, like we're streaming right now live, and we're talking all about the stars. Our next speaker is Adrian Bradley. Adrian has, that's right. Adrian has been on many global star parties, and he is always showing us mind-blowing nightscapes. And so we're going to turn it over to you, Adrian.
All right, so let's start. I'm just going to start right away by sharing my screen too. I've gathered all the images that I'm going to use, and some of them are probably, I'm going to spin it in a way that make you think that you're still looking at starscapes. So I'll start with the image that has defined the weather that we've been seeing lately. Lots of these clouds. Now this is back in the winter, but the snow has melted, but the clouds haven't really gone away. As I was looking at I think Bob Fugate's presentation, I noticed the attention to detail that he had, and I thought, what a great person to, you know, listen to the way that he gets his images. He knows enough about the equipment he's using that he's able to get the type of images that he does. And it's something that I've strived to do in my own images. Coming from a photographer side, if you are out there and you're interested, you're more of a photographer and you're interested in now transitioning to get nightscapes. I've had a few people say, I'm interested in doing nightscape photography or landscape astrophotography, whatever it's called. They could come from any kind of world, which is the world I've kind of gone back to. The world of bowling, where you're shooting in low light and you're trying to capture motion, and you may not always, the motion is a lot faster than when you're tracking night sky, but you're also trying to capture certain moments. With a certain camera, it might warp. The moments are warped, so I would have to seriously process this. Or I can just try, I can take other shots, and now I can get a good shot that's not warped. Now, these are local guys that are good at bowling, but I also had the opportunity to take some pictures of some professionals. You're looking at different images, and I'm going to somehow tie this to night photography. What you shoot at, you may get something that doesn't look familiar, but it's a part of what you're doing, or you may get something that looks familiar. This happens to be a professional bowler here that bowled the same sweeper that I bowled in. This gentleman has had his professional card as well, and you can see the similarity. And this gentleman with the two hands is also a professional. And, you know, you see in some of the photos I showed, you see some of the similarity. In the night sky, what people will look for is something similar. And a lot of the Milky Way photography becomes a part of a core. Why? Because it's a something similar that makes sense, that that we look for in photos to say, okay, I have a good photo because I got this, but there's a lot more to it. You can do birding photos, for instance, and Scott recognizes this as an osprey carrying dinner.
Yeah.
You can, or you can try to do something a little more dynamic and catch birds in the act of fighting each other like this. And you try and do something different with your birding so that you're not just catching the same thing, you're catching something unique that that isn't seen very often, such as a juvenile bald eagle flying upside down, yelling at an osprey because the bald eagle just stole his fish. So you come from that world of photography, take it with you into nightscapes. Here is the Cygnus region. When you're at a Bortle 1 site like Okie-Tex, which is where I'm going to be going soon, why not shoot at the Cygnus region? There's Cygnus. This is with a stock camera. Here are the telescopes here. This is what Okie-Tex looked like facing to the northwest, generally during the time that we go, late September, early October. It's a beautiful sight. I may try and get a few more images of this when we go down and shoot it with the modified camera. Why not try this and see what you get? Leave the sky glow in and see what happens to your overall picture. When you're coming from a photography background, and you may not know that this little thing here is actually the North American nebula, and the Pelican is hard to see when you're not using when you're not using HA or an HA modified camera, you can still see some of the HA light that comes through this with a 30-second exposure. You know, try shooting at that. The winter circle rises. Try shooting at that and see what you can get. You know, the Milky Way may not be bright, and there may be haze out, but that might grant you stars glowing bigger. The larger stars glow bigger, and you may end up with a really nice landscape, just overall landscape photo. In astronomy, the stars can take the center stage and the landscape is merely framing it. And if we go back to this image, that's exactly what I did with this is there's a cross at Billy Joe. This is about an 8-second photo. I'm going to actually look at that. I'm going to go file information. 8 seconds, f1.4, 50 millimeters. You can see M8 and barely the Trifid as well, M17, M16, the light from the Sagittarius cloud, the star cloud, and with 8 seconds of exposure because of the dark sky. With a little coma correction, I can get rid of this, the way that these stars are being, it looks like a big old circle here. But those are the sort of creativity that you can display rather than just looking for the same shot of the Milky Way going across. Look for different shots that show different things. The beehive is trapped in the zodiacal light here. These are the images I've shown on the show before, but it makes it very, very interesting. When you zoom in, you see all of these stars here to the point where there's just a lot more there than you expect. And this bright thing isn't a star, that's M41. Didn't have quite the granularity, so you can't quite get all the stars or any of the larger stars that are here. But everything you see here is out there in the sky, and capturing different things and trying to capture different moments is what makes your photography. It isn't so much as standing out as it is taking something different, learning from it, seeing something else that's in the night sky. And I'll end on the fact that here you have a nice picture of a sunset in progress. You could rename this a starscape because, well, the sun is a star. So that means this counts in some ways as a starscape, even if it's just a star of one and it's blocked by some nebulosity. And this is where you combine your terrestrial photograph with the things or the light that's in the sky, and you understand what it is you're taking a picture of. Something 93 million miles, and I hope I got that right, away, providing enough light and warmth and heat and everything else that it provides. And
the right distance.
The right distance. And don't be afraid to shoot straight at it. Just don't hold your uncovered sensor long. Remember what the Astronomical League says. Do not look at the sun directly without proper equipment. There's more, there's more to it. And do be careful when you decide to shoot at the sun. If it's too cloudy to get nightscapes, you can make some interesting pictures using the sun. So be creative with that. And don't be afraid to change exposure because you never know what you might get. So not only with regular terrestrial photography, you want to be creative with your nightscapes, your astrophotography. All of those were single shots. Those that read Skies Up magazine will recognize this one. This is a different region of the Milky Way that doesn't get a lot of attention because it's the Orion region. But landscape astrophotographers are discovering some of the things that they can do here in the Orion region, just because it's a very active, as far as nebulosity goes. It's a very active region and can be quite beautiful if imaged in a way that shows what's there. And in my mind, if you can do it without overdoing it, you get data that's really there, and it can still make for a beautiful image. So you don't have to compromise between detail that's there and a beautiful image, depending on how you frame all of your shots. And go out there and create. And there are formulas that you use there. It's about understanding your equipment, but it's also about seeing the image and saying, how can I capture that, bring that back so that I have a copy of that and I can share it. And in fact, this image itself, one of my favorite places to go that I use as a background for my computer screen, is another example of me just saying, I'm not worried about all of the man-made objects or even the slant of the wide angle lens. I just want to capture a moment in time where I was standing there looking at the lighthouse with the lake in the background and the Milky Way overhead. And I ended up with this photo. I can always go back when this scene repeats itself and see if I can do something a little bit different to mark the passing of time, to in contrast to this photo. The deep sky astrophotographers, we shoot the Orion Nebula over and over again, but each shot that we take teaches something new about the image. We may pick something up in the Orion Nebula that we normally don't, or we may shoot the Orion Nebula and say, this time I want the trapezium visible. How do I do that? We just had a talk on that. And each time, even if you're shooting at the same image, be creative and see if there's something different you can do to show something, another aspect of that image that that teaches you something new about it. Let your photography help you discover things, and not so much, I want to get a good picture. I can't wait to put this on Instagram, and I can't wait to see how many likes I get. You do it for the science, and you may be surprised how well the image comes out, because your focus is on seeing what you can learn with the equipment that you've got. And so, Scott, that's it. Hopefully you liked some of the bird photos I snuck in there.
I love them.
And
I really enjoy many.
Adrian, I have a question. So any
Yes.
eagle can be a stellar sea eagle? Sorry.
Say it again.
I said any eagle can be a stellar sea eagle? Stellar.
Just about, especially if you shoot at the Eagle Nebula. If I had a shot, the only shot I had at the Eagle Nebula was this little pea-sized thing. So I couldn't make if I were to go in there and do some deep astro and then put the two side by side, pillars of creation and the eagle flying backwards, I think the eagle was just about in the same orientation. That would be a cool shot. I'll have to put that as a goal to get a real Eagle Nebula. Well, they're both real. That's the one thing about this. All of this stuff is real, and it's a joy to capture it on a CMOS sensor and present it. So excellent. Yep.
Yeah, you
Great
had
question.
some great images there, Adrian. That was
Thank you.
fantastic. The nightscapes were fantastic. And you really actually, I'm not going to look at things the same now that you said about the sun being a starscape. That completely changed my perspective in terms of
Good.
daytime shots and the clouds being nebulosity and so forth. That's fantastic perspective.
Yeah.
Really like that.
Yeah, a lot of our problem when it gets cloudy or some other limitation comes, what do? We shut off the rig and we go inside and we watch YouTube videos on how to better do our astrophotography. But if we look at it and say, well, what would it look like if I shot it through the clouds? That's part of what the landscape astrophotography, it's like or as I call it, nightscapes, because sometimes there isn't much in the way of astrophotos, but the combination of which teaches you something else, the starlight coming through it. And if it's okay if I can find this photo quickly, I like using it because it's an example of, well, if all else fails, just shoot what you got out there. I went to image and it got cloudy as I was going, and I'll see if I can find it. It's the dippers, Northern Hemisphere, as the clouds were coming in. And I think this is it right here. So I'll do a quick share for you all. This is it's one of the images. So I'll go with this. So here you have the winter hexagon region. It's cloudy, but you learn that bright stars get bigger. You can buy filters to do this for clear skies, or if you shoot when it's cloudy, you get this sort of effect. I had one of the images where I did this end up in a calendar at my job because they thought it was cool. And this is the whole, well, there's a lot of clouds here, so that Explorer Scientific rig that's shooting at Orion right now probably isn't getting a whole lot. But you can still see 5th and 6th magnitude stars of the Little Dipper with this exposure. You can still see the stars of the Great Bear, and Leo's getting stretched a little bit over here, where the stars are really thick. And then there's also light pollution here from a neighboring town. You're not seeing any stars, but up here, you're still seeing stars, even though my tracking didn't go so well. But you're still seeing the bright round stars. And this is interesting too. The bright round stars, if your tracking's not that good, but you've got a bit of a haze going, you get dashes, but you still get round stars. And the major stars do be the pointer here. And I think this is Murak. I know that this is Alcade. I used to look for M51, the light from M51 coming off of Alcade here. You'd barely see it. I can't tell you that that's it or not, that there's light. It would be nice if I could tell you that there is light from a galaxy 51 billion or 51 million light years away peering through our clouds. That would be awesome to tell you, but I can't because I'm not 100% sure that is light, but it is in just about the right spot for where M51 is. It's close. So I would have to look at it and make sure that that's exactly what I was looking at. But that's a part of where you say you can take any simple image, even this, and you may discover you captured something you didn't realize you captured. Just like comet hunters look and go, what's that? I didn't expect it. You can do that each time, even with a wide field shot. You may capture something that surprises you. So it keeps you going.
Thank you, Adrian. Thank you. Up next is Lisa Ann Fanning. Now, Lisa's new to the Global Star Party. She was recommended to us through Professor Kareem Jaffer, which I'm very glad. I always love new faces to come on and to make presentations. I did learn that you kind of got your start with the Royal Astronomical Society of Canada. Correct me if I'm wrong, the Halifax Center, and that you are a relatively recent member of the Astronomical Association of Astronomy of Princeton. Is that correct?
Yep,
Right?
I live down in New Jersey.
Yeah.
Even though I'm a RASC member.
Yeah, that's awesome. So tell us a little bit about yourself. You're making presentations, and you've caught the attention of some great people, and so we want to know more.
Sure. So here's a little bit about me. I've always been a bird appreciator since I was a child. I grew up in Brooklyn, and actually, after today's events, my heart is in Brooklyn tonight. So Brooklyn strong. I did love watching the gulls at Coney Island. Eventually I ended up moving to Manhattan, Boston, and over to New Jersey. So that love of birding followed me all through those states as well. I did become a full-fledged birder, in 2010. Sorry, I had to do it.
Well, Lisa, I'm glad I shared those images with you. So you were looking at those things to see if I did right.
I was. We're going to be in touch.
All right.
I do volunteer with working with beach nesting birds here on the Jersey Shore, and I do perform other birding outreach as well, such as field trips. I met my husband Rob in Cape May. We were chasing a rare Henslow's sparrow that wound up in a field, and he was standing next to me, and I heard violin music and all that.
Awesome.
I started appreciating the night sky more in 2019. As many birders go through, I did come up with a bout of Lyme disease, unfortunately, which sidelined me. And the medication, which is doxycycline, makes you very sun sensitive.
So this is actually a common ailment with birders?
With yeah, Lyme disease, unfortunately, if you're bushwhacking, you end up with ticks, and here in the Northeast,
Sure.
it's just an awful problem. So I was kind of bummed out because I was feeling all these things that I was losing, and I couldn't go birding. My husband said, "Hey, let's take the spotting scope out. Let me show you Saturn," because he had taken an astronomy class in college and wanted to cheer his wife up. Happy wife, happy life. So he put Saturn in that spotting scope, and my gosh, I was hooked from there. I bought John Reed's book, and because I just wanted to learn more. And then in the summer of 2020, I was sparked by NeoWise and decided I wanted to take this to the next level. So I joined RASC Halifax and did their Explore the Universe program, which I highly recommend for anybody who is looking for a start to learn how to navigate the night sky. From there, I was asked to become the editor of Nova Notes, which is RASC Halifax's newsletter. I'm also a member, as you mentioned, of the Amateur Astronomy Association of Princeton, New Jersey, which is about 40 minutes from where I live. I do run my own astronomy Facebook page, which came directly out of the pandemic, ironically enough, because people were feeling that same sense of loss that I did when I had Lyme disease and couldn't go do the things that I wanted to do. We found ourselves in a situation where we were all on lockdown and couldn't go to the park. So I started issuing these challenges to my birding friends and said, "Hey, go out there and point your spotting scope, take your binoculars, just point them up at the night sky, and you'll be amazed what you can see." From there, I started to see that my posts were going global, literally. So I started my own page back in July of last year. And that's how Lisa's Lookup was born.
Wonderful. Wonderful.
So quite an interesting journey for 2 years.
Absolutely.
So I did want to focus tonight on migration and the moon. And it's not just for the birds, even though that's what I'll be focusing on tonight, but I did want to talk a little bit about insects and some of the studies that have taken place around periodicity study for insects that started in 1927. So this goes back a ways. And of course, I think many people know that bat behavior is affected by the moon, but also remember that they're dependent on insect activity. So that is definitely influenced by the moon. But what I love, songbird migration and the moon phases. So this quote, I love this quote because it was once thought that birds migrated to and from the moon. That was a quote by Charles Morton, who was a 17th century English minister and scientist. This was taken in 2020. This was fall migration. And I was standing outside and working on my Explore the Moon certificate for RASC. And I realized that I could see the birds migrating in front of the moon, which is such a neat thing because here are my two passions. And so these are captures just with an iPhone and a single shot. The one on the right, I was playing with Starry Sky Stacker and was able to stack images of two birds going over the moon and their transition. So this is a fun little challenge that I'm going to issue to the audience here today.
Beautiful.
I thought I invented something new. I was ready to cash in on my millions, but nope. So this idea of moon watching for migration was first described by George Lowry and Robert Newman in the 1940s through the 1960s. And they figured that if you point a telescope at the illuminated disk of the moon, you can facilitate the ability to see birds migrating at night. So I had to, unfortunately break that deal with the house that I was going to buy on the beach. So. So this definitely piqued my interest, and I started digging deeper and found that there was a great study done out of Lund University in Sweden that was published in 2019, and they looked at European nightjar migration and the moon. So they charted the activity of 39 European nightjars. So this is the cousin to our whippoorwill or the poorwill family here in North America. And of course, they discovered nocturnal hunting activity for flying insects doubled on moonlit nights, because that's when the bugs are out flying around. But even more interesting, they found that the birds would all depart for autumn or southbound migration consistently 10 to 11 days after the full moon. And they found that this species was synchronizing their migration and flew off at the same time. So that definitely got me going and started crunching some numbers on my own. This is NexRad. So for anybody who's not familiar with NexRad, here in North America, we have access to the Next Generation Radar, or NexRad for short, and they're real-time maps that show concentrations of migrating birds, bats, and insects. And Cornell Lab of Ornithology actually produces these maps, but it's a whole consortium of organizations that have helped to underwrite this effort. And what I did here was I mapped out the bird migration. This was southbound migration in 2021 of the full moon on the left versus the new moon. And you can see consistently that the migration traffic rate is much higher on the full moon. So this is just one demonstration looking at those 2 days. I took those numbers even further and I decided to crunch them and chart them. And you can see the dips around the new moon. Sure enough, if you look at that full moon of September 20th, you see a peak. Now I'm going to point out something that's a little skewed here, but right before the new moon in October, you see a little bit of a peak and then the dip at the new moon. So here on the East Coast, we had an awful run of weather, and those birds were backed up for migration. So that anomaly can definitely be explained away. So songbird migration and moon phases. This is where I'm gonna issue the challenge. That's video I took recently last month of a bird flying over Copernicus crater, and the conditions were right that night for northbound migration. So this was March 16th. This was at 10 o'clock Eastern. I was just out pointing my scope at the moon, and we had winds from the southwest, which are ideal for bird migration. And the moon was 97% full. So I would say for the hour that I was out there, I encountered maybe a dozen or so of these birds without keeping official count. So April is sort of the beginning of migration here in New Jersey. And so I'm going to be out there with my telescope next full moon for sure, tracking this. So I said I was going to issue a challenge, right? How can you try this at home? It's really basic equipment. If you have a spotting scope, a telescope, which I think many of us in this audience do, you can even watch it with binoculars. A cell phone if you want to take video or a snapshot, and a smartphone adapter for recording video if you want. I do tend to freehand, but smartphone adapter is a lot cleaner and a lot better experience. You want to consider your timing. So peak northbound migration begins in March or April. That's starting in Point South. So along the Gulf Coast, that's when it starts. When you move up the coast, for example, in the Atlantic Flyway, we're looking at peak migration. We're getting there now in April, but May is the hot month. So consider where you are in this map. And then peak southbound migration begins in July and August from Canada. It also does depend on species. So we have shorebirds departing here in New Jersey around July or August. But when you're talking about songbirds for New Jersey, October is the hot month. So choose a night around the full moon. I usually recommend plus or minus 3 or 4 days for best results. You want to check the winds, as I mentioned, northbound or spring migration. You want that southerly component because it pushes the birds. Birds are very energy efficient, so they're going to go when the winds are in their favor. Same for southbound, but you want that northerly component. You want to set up your optics as you would for any moon observing session. I always recommend taking video because you can always extract it. Also try slow motion video. And then once you have your images, you can even extract them and stack them like that second photo that I showed originally, where you see the two birds crossing the moon and you see their path. So I just wanted to say thank you. And thanks so much for this opportunity. And if you have any questions, you can contact me through Lisa's Lookup on Facebook. If you want more information, or just message me. I love to talk to fellow bird and astro nerds. So thank you.
Well, Lisa, I just joined your followed
All
your
right.
page. So you've got at least one new subscription already.
Awesome. I want to see some pictures. That's what I want to see.
Yep, I guess I should send a friend request.
Yeah,
I don't
definitely.
know if that'll
Right on.
Yeah, if that'll work. Yeah, I'll send a friend request.
Lisa, can I just ask a quick question? It's Shawn. I was just wondering if you could demonstrate on NextRad how you got the bird migration map and stuff.
Demonstrate it live, sure.
Yeah,
Give that a
is
shot.
that possible? Yeah.
I'll give that a shot. Let's see.
Just so people can see where to go and how to do it, how to access that information.
So Birdcast is the real-time bird migration maps. Let me change my my sharing here. Okay, can you see that?
Yep, I can see it.
Great. Yeah, so that's birdcast.info.
Okay.
And here is the team that puts this together. So I mentioned there are a lot of people. NASA, I think, also is one of the underwriters. So here are the migration tools, and they do it around the peak season. So here there's a note saying that the forecasting will end around June 1st. So they'll shut that down when there isn't migration going on. So this is specific to the bird migration forecast. Here's
Awesome.
tonight.
Okay.
So they're predicting 104 million birds will pass through the US tonight.
Wow, that's incredible.
And then if you look over on the right of the birdcast, you could see the migration intensity. You could see where it is. It's low in the west right now, but medium-ish, if you will, in the central and eastern flyways up to about New York State.
Do you know of any maps such as this that display the migration paths within Canada, since that's where I am? Is there anything that you're aware of?
I am not aware offhand, but I can certainly
Okay.
pass that information. I'll look into that. It's a good question.
It would just be interesting to see the Canadian component of the migration paths as well.
Yeah. Because that's definitely going to start to heat up as well in the next few months.
Yeah, for sure.
Cool.
I guess
know
we
if
can
anybody-
pass it back. I don't know if anyone else has anything else to say, but I guess we can pass it back to Scott. Is Scott on mute?
Yeah, I just sent a friend
Oh,
request.
I'm muted. That's right.
Yeah, you were
No,
muted.
there's
Scott.
something called the Canadian Migration Monitoring Network.
Oh, okay. All right,
Yeah.
great. I'll look that up. Canadian Migration Monitoring Network.
Canadian Migration Monitoring Network, the CMMN. It's on birdscanada.org.
Oh, okay.
It would be interesting to put these two maps side by side, I think, on a heavy migration night and see, sort of where it stops, because when birds hit weather, they'll get grounded so it'll be interesting to see if they continue on to Canada on one particular night, or if they're grounded, they hit weather up in New York State or Vermont. That'd be interesting.
So it's not a heat map like this is. I mean, this interactive heat map is really cool, So, but there are resources out there for sure.
Yeah, look into that. Thanks, Shawn.
That's great. Thanks, Lisa.
Thank you.
Great. Yeah, it's also, Lisa, one of the other things to point out is the importance of dark skies to birds.
Absolutely.
Since the majority of the migrations happen at night, there are, unfortunately, they get turned around because of bright lights from cities, and from tall buildings. There's millions and millions of birds that die from bird strikes on buildings. So, I'm not sure what the fix is for that, but certainly, maybe smart lighting practices where lights are turned off and they don't need to be used. There are so many, you can drive through a lot of cities and you see like all the lights on in an office building and no one's working, so.
They say that even 20 minutes makes a difference. I before the pandemic was working in Jersey City, and on following heavy migration nights would find lots of dead, especially white-throated sparrows, certain species in particular. Woodcocks tend to hit buildings in big cities.
Yeah. So.
Yep.
Yep. And so save some money, turn off the lights, save a bird, right?
Absolutely.
Or save a
Or a
lot
million.
of birds. Yeah, a couple of million birds. Lisa, thank you so much for coming on, and I think it's about time that we took a 10-minute break, and there's a little feature in there as well, and I also like to do some shout outs for the people who write books in our program, that appear in our programs. Of course, David Levy's autobiography is there, and David Eicher has mentioned a children's book a couple of times, so I did a little video plug for that as well, so you'll see that. But that's by Mike Bakich and David Eicher. They collaborated on that children's book about space exploration. So you're welcome back anytime, Lisa Ann. And we also, being that you're so much into birding, we'd like to have you as a featured guest on our On the Wing program, which is all about birds. So
I would love that. Thank you.
We'll hit you up.
Pleasure.
Okay. Thank you very much.
Not fun.
All right. So it's time to go grab that sandwich and stretch your legs and take a little break. And then we're going to come back with Jason Guenzel, The Vast Reaches. We have Marcelo Souza from Brazil. Cesar Brollo joins us once again from Argentina. And then we end with Maxi Falieres, also from Argentina, with Astrophotography to the max. So we'll see you in a few minutes.
So Lisa, after you mentioned the Lyme disease that afflicts a lot of birders, I decided I must be a fair weather birder or a concrete street birder. If we do have a metro park here, Kensington Metro Park, it's quite a nature preserve, and a lot of people shoot at this park. There's nests built, osprey obtain it. There's bald eagles there, great blue herons. You saw some of those in the pictures. And so a lot of us are spoiled. We just show up with a camera, sit on a park bench, take aim, and nature just
not a bad way to do it.
Not having to walk through any of the brush to get to the action, having to sit still. Don't even need camouflage on your big lens. You just show
us
up.
Crazy listeners, we got to get that one extra species, so we have to bushwhack.
Yeah, I have a friend who does that, and he's he's very good at getting the species. That sharp, beautiful photo isn't his thing. His thing is he's got like 100 or so species under his belt, I think, or he's trying to catch somebody who has even more than that. So
right.
Like I said, that's a serious birder. So
I was younger and crazier in that once.
I salute all of you who know a lot of species. I generally know the common 7 or 8 that we see at some of our metro parks, and
Hang around me and my
anything
husband
different.
will teach you everything you need to know.
Yeah. When it's cloudy outside, that's the other thing that gives me peace.
Oh yeah.
But
Oh yeah. I'm waiting
yeah,
on the hummingbirds to come back. I can't wait. It's any day now.
yeah, I got one good hummingbird photo, submitted it to one of the nature Facebook pages, and it ended up being the cover page for about a week.
Oh,
Like I
sweet.
said, capturing the hummingbird it's just cool to watch it go. And it reminded me of shooting at the butterflies. It was almost the same type of thing. It's like, just shoot fast, shoot quick, because those things, those wings fly. I actually froze the wings on a hummingbird.
Oh, sweet.
Yeah,
That's
I had to do some editing. So Shawn, the editing that you learn from editing nightscape photos, some of that goes into the birding editing too. Topaz denoise, which is one of the tools a lot of people are using, because it's gotten really good at separating signal from noise really well. Well, it does the same thing for birding photos too. It'll separate and I almost think it was originally for birding shots, and then it's like they've tweaked it every month or every few months to get better and better at different kinds of images. And it really does, the birding images, it does really well. I've had images like the low lighting images that I took, I threw those through Topaz denoise, and it gave me the type of image I was looking for. And I've been happy with it.
I actually haven't tried Topaz denoise at all. I don't do any birding shots and stuff like that, but that I would need to use something like that. But I've heard good things about it. So Adrian, do you do most of your processing in Photoshop or Lightroom?
I do most of it in Lightroom for tweaking colors and things, like the image behind me, but I'll take it to Photoshop and run the Astro tools. They've got the enhanced DSO objects. That tends to work well with Milky Way shots. It tends to it brightens the Milky Way region without screwing up the land. If you have some sort of landscape, you got a mountain or you just have a mesa because that's all you can afford right now. But it doesn't ruin the mesa so much as really it still makes the Milky Way stand out a little more, no matter what part of the Milky Way you shoot. So so I use Photoshop for that. I use Topaz denoise somewhere in the process to, if the shot yielded a little bit of a noisier, if there's a little more signal to noise, I will send it through Topaz denoise and let it clean some of that up, send it to Photoshop to brighten up whatever part of the sky, and then use Lightroom CC to just do the final edits where I'm doing things like their dehaze slider that darkens the sky a bit, gets me more of the basically getting more of the contrast that I want out of the full image, however that looks, without trying to overdo it. I haven't gotten into using PixInsight, and it looks tempting for all of the way that it can be set up. I just have to sit down with you or anyone else and just say, all right, let's go through step by step. Here's a image, the pink image from the HA camera of the Milky Way over a lake, because it's my favorite thing to shoot. And now it's time to turn this into something usable. And what do we do? So I would be,
well, we'll have to do that
I'm getting to the point where it may be worth it to set up PixInsight, because it looks like you can just run through a few scripts, and your processing is basically hit a button and have it go through the routines that you want it to do to your image. And if you like the result, export
To
it
some
and post
degree.
it.
Yeah, to some degree, it's not. It's a little more involved than that, of course. But there's a lot that goes into setting up the processes, the parameters, and so forth, and getting the right tweaks done to them to apply it to the image before you apply it to the image. But I've actually never done in PixInsight a Milky Way shot. All of the work that I do in PixInsight is deep sky objects, right?
Yeah.
So I'm not sure how it would lend itself to something like a Milky Way shot, but it would be interesting to try. That's for sure.
Yeah, I have Astroflat, which is nice when I do actually try a deep space shot, and that looks like it works really well. I tried it on a full picture, and it broke the landscape. I think there were gaping holes in the landscape, and then other things went wrong. So I said it's a little too much. It makes the sky it takes care of all the gradients in the sky, but it takes the ground right out from under you too, and then you've got a weird looking kind of image. You lose your light tower that you wanted to be a part of it. So I can see the pink reflecting from Scott's screen.
I was going to say for you, Lisa, I'm not sure if you're familiar with Flap Canada. No? Okay. It's hard to talk over the music, but Flap Canada is at flap.org. And they have a lot of good information on there. They're very active in outreach, educating people about birds and the challenges that the birds are experiencing right now with regards to urban design, but also light pollution and so forth. So it's a really great resource. It's got a lot of good information on there. It might be something useful to you.
Flap.org.
And flap.org. Yeah.
I'll check that out for sure. Thanks.
Yeah, check it out. Just something I thought you might be interested in. I also follow, there's a website called Journey North, and they track the hummingbird migration. Actually.
Yeah, that's so neat.
Yeah, and they actually have a map that is a user interactive map where you can take photos of the hummingbirds that you see in your backyard, and you can post it on the map, and you can actually get a visualization of where the hummingbirds are, how they're moving along as they do their migration north and south.
And that's a great website. And people get excited about that.
Yeah.
I gave a lecture about creating hummingbird gardens at our local garden center with my husband, and very well. You get excited when they know they're coming.
Yeah, absolutely. Yeah. It's too bad we couldn't mute the music. I could hardly hear. I was trying to talk. Well, you're muted, Scott.
Right? Well, that was
There you
better
go.
than being on the
There you
screen,
go.
that's for sure.
Yep.
So we're back. Hopefully you enjoyed that little break. And Shawn was talking about a website called Flap. Is that right?
Yeah, Flap Canada. So it's flap.org, and they have a really good website, very resourceful website on birds, the challenges that birds are experiencing in our environment, in our urban design that we, buildings that we build, and also light pollution. And they also have strategies for how you can help the birds, things like bird safe windows and solutions for commercial and institutional buildings, as well as residential and that. So it's really good. And the other website I mentioned,
they're talking about bird
yeah.
death counter, and it's like the numbers as I'm watching is racing up like crazy.
Yeah, it's incredible the number of birds that get killed due to impacts with buildings and whatnot. So and it happens during the day and it happens during the night. So The other one that I'd mentioned, Elisa, was Journey North, where it's an interesting website for the map that shows the migration of the hummingbirds, and it's user interactive. So anybody with a camera can take a photo of the hummingbird in their backyard and post it to the website, and you can actually get a visual where the hummingbirds are, what type of hummingbirds are where along the migration route as they progress through it. It's really interesting.
Excellent. I'm posting these in the live chat. So yeah, for those of you that are interested in protecting birds, and you should be, because protecting nature and birds amongst all the other things in nature directly linked back to us. We're not somehow disconnected from all this stuff. So right?
That's right.
So
Yeah.
if you're interested in just protecting yourself and your family, you need to be.
I would also add, New Jersey Audubon has a lot of great resources. Lights Out Baltimore does a fabulous job at talking about mitigating those risks, and some of the studies about turning lights out for 20 minutes. And Chicago Audubon also has great resources.
Great. All right.
So now you all see that Global Star Party / On the Wing tonight. We love both birding and the night sky. The two are related, and
That's
Lisa
right.
just
It's
showed
all
you how.
connected. That's
And
right.
there is a
primary
connection.
lesson of the Global Star Party is that everything's all interconnected, all interdependent, and
Absolutely.
so that's right. It's all part of the universe. Well, next up is Jason Guenzel. Jason is an amazing astrophotographer. He has been on Global Star Party several times. He has very popular social media outlets, and where he posts his images. But I always love to hear about Jason's journey in astrophotography, because he's not too proud to show his very early attempts, in contrast with where his journey has taken him. And those images are nothing short of breathtaking. So Jason, you've got the stage here. Thanks for coming on.
Yeah, thanks for having me again, Scott. I don't have anything old to show you, and I don't have anything bird related, so I'm sorry about that ahead of time. Yeah, boo. But I live near Adrian, and I can feel the pain with the clouds and not getting a lot of astrophotography done. So I've gone back and reworked some older images, and worked on some that I shot earlier in the season and never got to. So that's what I plan to show everyone. So let me share a screen here. I'm sharing a different screen than I'm working on, or that I have the meeting on. Hopefully this comes through. Let me know if you can see it.
Yep, it's coming.
All right.
There you go.
So
Wow.
we'll start off with the topic the subject that needs no introduction, right? I think most of the people on this meeting and watching out there know a little bit about this target, may have not seen it in this type of exposure before. So I'm going to kind of blow this up.
Jason, I have seen an image like this before, but it was a combination of all different kinds of telescopes that made the images. Is that similar to what we're seeing here?
Yeah, so I'll explain a little bit about what you're seeing. So this image was shot entirely through a 40 millimeter aperture telescope, the TPO ultra wide. So it's a 40 millimeter aperture, 180 millimeter focal length, tiny little telescope. The telescope's about the size of a can of Red Bull. And then I've got an ASI 2600 camera on the back with a big filter wheel with 2-inch filters. So the camera and filter wheel assembly is this massive hunk of optical machinery on the back of this tiny little telescope. But the advantage to that tiny little telescope is it shoots a very wide field image, and a fairly well corrected one too, out to the corners. We're getting sharp stars, and so it's been a lot of fun shooting with that telescope. And this is one of my early images with that scope. This is the Belt of Orion, or the Sword of Orion region, with the well-known Horsehead and Flame Nebula there on the left, and then the Orion Nebula off to the right. It's cool to see it like this, because it's unless you see people present images with a telescope, or sorry, a camera lens, or a mosaic, like you said, Scott, of multiple different shots. It's hard to get this field of view, but it's possible with this system. And it was shot with the luminance as narrowband light. So I've got a Radian Triad Ultra, which is a multi-narrowband filter, and I use that in front of a monochrome camera to shoot a narrowband image, basically collecting hydrogen, sulfur, and oxygen light, all for the luminance information. And then I went back and shot through red, green, and blue filters to present the color image in natural color, although the natural color is overlaid on top of a narrowband image. So it's a little bit of a unique way to look at it, and a little bit different than a lot of them you see out there. So, I was really happy with how it came out, in the depth of exposure in the dim areas, and also, some of the details in these areas that are, not only these bright, commonly seen areas, but some of these dimmer zones where, you just don't normally see those presented in an image. So it's a lot of cool undulating waves of hydrogen gases out there.
It's beautiful.
And then, over here, it's, what is this? NGC, it's 1999. It's a little H2 region. And inside there, it's got the tiny little keyhole nebula. I don't know if anybody's familiar with the Hubble image of that, but it's a little tiny window into the background space here, right within all this nebulosity, and the Running Man Nebula, Orion Nebula. And it was shot with a HDR process to preserve the details down into the core of the Orion Nebula.
Jason, what's the integration time on that?
Total is 13.3 hours. So I shot,
okay.
I don't have the breakup here, but I shot the majority of that, probably 8 to 9 hours, was with the Radiant Triad Ultra. And then I shot a little bit of luminance to bring in some of the dusty nebulosity that's not captured in narrowband. And so that's blended in there, and then RGB for the balance. So the total is 13.3 hours.
Nice. It's a fabulous image. Really fantastic.
Yeah, and something I've been doing, I appreciate that. Something I've been doing with a lot of these recent images is now that we're in this arms race with star removal software, where we've got Star Exterminator and StarNet both releasing better and better versions, it's a lot easier to remove stars from your images and process the star layer and the nebulosity separate. So I ended up with a purely star layer and a purely starless image where I can just click on and off the stars. If this will refresh. I am stacking something in the background, and there you go. You see that?
Right.
Where
Oh,
starless image. I mean, love it or hate it, it really allows the eye to concentrate on the details of the nebulosity behind. Even with the star field I had on there was minimal. It does really help to pull the stars out, and you can just see all the details.
Yeah, I think there is some use, especially when what you have is accurate. You can focus on that. The stars, I think, just give it sort of if I were floating around in space, that's what I would actually see, is a ton of stars. And I'm actually thinking you'd see way more than that.
Yeah.
Than when you add the stars back in. But if you were floating around and had on your filter visions where you could see things like this,
right,
I think you'd still see tons and tons of stars. And it would just be a part of what you're looking at. So I think there's value in all of it.
Yeah, so I shot another image here with the same process. So this is the flaming star, tadpole nebula region.
Wow.
What is this? M38, I believe, this open star cluster down here. So again, it's a expansive view. I think it's 5 degrees by 7.5 degrees field of view. Just a massive field of view. And this is in Auriga constellation. You know, it's a popular target, but it doesn't get as much attention as the Orion and Orion region, which is right south of it. But again, we can do the same sort of thing where we click on and off the star layer. Man, my computer is bogged down. I apologize for this. Maybe it'll refresh.
It's a big image, right?
Yeah, I've got a lot of, I should probably start closing these. Yeah, each one of these images then, because I drizzle this data, so each one of these is about an 85 megapixel image. So yeah, I've got a lot open here. But you know, these areas look cool, and you know, a surprising amount of detail coming out of a really tiny telescope.
It's like 2 eyes and a beak, like maybe some sort of raptor bird, maybe like an owl or something.
Yeah, I don't
See,
see that.
we just tied your image to birding again. So we made it happen.
You said you couldn't do that, Jason, but here you are.
Oh, you know what? Let me do this here. Yeah, I think if you turn this, let's see, counterclockwise, yeah. Then it really starts to look like a bird. You can see these 2 eyes in the beak.
Yeah.
Oh man, see, look what I'm doing to myself.
The detail is just phenomenal.
It is incredible.
You ever seen it take this long to rotate an image?
Yeah, when I only had 4 meg of memory, 4 gig of memory in my computer. Everything took that long.
Full disclosure, in the background here, I have my telescope outside and it's looking at the moon. So I've got a live view of the moon. I also took images of the moon and I've got it stacking in the background. So that's why this is barfing at me. But
so Jason, the scope that you use there, is that similar to the ASCAR FMA 180?
It is the same telescope, different color.
It's just a different color. Okay, all right.
Yeah, I mean it's the same telescope. It's just it's branded and sold as a TPO, which is OPT's house brand.
Okay, all right, that makes sense then. Yeah, I actually have one of the FMA 180s, and now you've got me interested in using it.
Yeah, I mean the field of view is just awesome. Unfortunately, like now with it being, you know, galaxy season, like in the middle of the night, there's nothing to shoot because no galaxy looks good this wide. Unless you're looking at Andromeda.
Well, if you're going you go at Virgo, you can make yourself a deep field.
We'll skip off that. It's taking too long to rotate that one. All right. So this is the Siamese twin galaxies. These are interacting pair of galaxies. Shot this one last year. Finally got around to editing it. This was shot on the 8-inch Edge HD telescope. And I've got 19.75 hours in here, LRGB natural color.
Beautiful.
I don't have the distance to these right now, but
which objects are these again?
They're called the Siamese twin galaxies. Well, they were, and then NASA realizes there's a little bit of insensitivity in that name. So they changed it to the butterfly galaxies, but I have the numbers here. It's NGC 45, 67, and 68.
45, 67. Virgo cluster galaxies, is that what they are?
I believe
they're in Virgo somewhere.
Yeah. Virgo cluster. These guys are about 60 million light years away.
Yeah.
What's their new colloquial name now?
Well,
the butterfly galaxies.
Okay.
Yeah. So yeah, they're listed both, you know, butterfly and Siamese twins.
Okay, so they
Yeah.
for reference.
Yeah, but August 5th, 2020, NASA announced they would not use the nickname Siamese twins. You know, so
So the other cool thing, like I was talking about, star removal software, that software has gotten smart enough to now if you feed it a galaxy image, it will remove the Milky Way stars, but it leaves all the background galaxies. So that's actually what you see in this image.
that's pretty cool.
No stars,
Yeah.
just all background galaxies.
Those are all
captured.
galaxies.
Yep.
I was wondering that when I saw the image. I knew you had a lot of other galaxies in there, but now you've just shown me which ones really are the galaxies.
Yeah. So I mean,
clusters.
if you look at, the reason the star software doesn't take these away is because they're not circular objects. So they're extended galactic objects. And you can go in and verify that these are all
Whether they're really all galaxies.
non-stellar objects, but yeah, there's
Incredible.
Yeah, I thought StarNet or PixInsight worked with where it would actually plate solve, so every little dot on there, it would decide if it's a star or a galaxy, and it would use that.
I don't think it's that involved yet. I see that technology could come along at some point, but I mean, right now it just looks to see if it's a round object, and if it is, it takes it out.
Okay.
So in this image, is there this is there any kind of this integrated flux nebula between the two closer components? It looks like there's like this sort of ring or down towards the bottom.
I don't know if you would call it integrated flux nebula. I mean, but it is, they're interacting, and there is like a stellar stream or around the outer lobe of this lower galaxy. So along these lines, I also have a second galaxy image to share. This is not that one. This is M100, which is a fairly well-known Messier object. And this one was shot with in HA LRGB, and this totaled 28 hours of exposure. And you can do the similar sort of thing.
Do you do all your processing in Photoshop then?
I do. No, I do all my stacking and initial work in PixInsight, and I move to. I usually move to Photoshop after I stretch it. And
I see.
I do the rest in Photoshop. I'll use some tools occasionally. Go back to PixInsight for it, but mostly I stay in Photoshop. I just a little bit more free.
It's a great image. Really fabulous details in there again.
Yeah, I like this core because it looks like a blown out blob at this scale, but if you zoom in on it, come on, computer.
Look at that.
There's quite a bit of detail down in there.
That is amazing.
If you ever get a chance to look at the Hubble version of the core of this galaxy, it's amazing. But it's a classic grand design spiral. And again, with the stars turned off, everything you see here are background galaxies and smudges. So a couple weeks ago, I was after a night of deep sky imaging, I had the telescope out, and the sun was up just above the horizon, and I saw Venus shining there. So I pointed over there, and I took a shot in near infrared and RGB. And that's, I love doing these crescent shots of Venus with them tilted up on their side like that. But
it reminds me of something out of 2001: A Space Odyssey. I mean, it's just
it looks like an album cover from the 80s or something.
Absolutely.
I had some fun with the colors, obviously, but the planet Venus this is shot in RGB filters, so
you've got some sort of shine there because you've actually got the whole disc. So what's throwing
you can capture the dark side of Venus. there's no doubt I helped this one along a little bit, but
Okay.
I've captured in the past the dark side of Venus in near infrared. So it does glow because of its heat signature.
Okay.
Around 1,000 nanometers, if you can get a filter that isolates that, you can capture the dark side of Venus. And I've got, many images where I've captured it and I've tried to extract detail, because you actually can see surface or sub-cloud features with a
cool.
near infrared feature, but I've never actually gotten detail. The problem you have with capturing the dark side of Venus is that the light side is so bright that it washes over the image. So you've really got to take care with gradient removal and all kinds of tricks to get the dark side detail.
Right. Yeah, I was like, well, that's not Earthshine. So thanks for
No,
the
it's not.
explanation, because I think that's the first time I've seen your image like that before, but it's the first time I'm looking at it and realizing, wait, that's a full disc.
Yeah.
So yeah, that's, when we look at it through the telescope, we never see the full disc. We see some form of the crescent. This is also a really good composite right here.
Yeah, so this past week, we're coming up on 2 years until the next total solar eclipse that's coming across the US. It's actually going to be April 8th of 2024. So in honor of that, getting ready for that, I kind of went and retouched the totality image I shot in 2017. And with 5 more years processing experience under my belt, I've always wanted to dig down and get these coronal loops that are in close to the sun. And that's kind of what I focused on for this image.
Now, did you pull up the shadows enough to get the actual Mare on the moon as it appeared?
Yeah,
during the eclipse.
That's from the longest exposure shot. I think I shot a range of exposures from like 4,000th of a second all the way up to, I think I went up to like 8 seconds, which was pretty blown out. But that moon, that's from the exposures. This is all.
Yeah. So that's where the moon, where the Mare were, if with superhuman vision, if you looked and saw it. I always wondered if you could capture that, and that gives me ideas for this solar eclipse coming up.
Absolutely.
I may try.
I didn't superimpose that moon. That's the image.
That's it. So. That is the moon. Yeah, that is always cool to see, because you're looking at it's like looking at the moon the way we see it at night, even though it's it's darker, but those features are still there.
Yeah, and I do a lot of solar imaging and capturing prominences and stuff. It's amazing that I was able to dig out all these loops out of that data.
I'm
stuff
seeing
that
all
I just
those.
kind of blurred over my first time through. So I really had a lot of fun revisiting this one. Really proud of the result. Finally was able to get out of it 5 years later.
Yeah, I think I saw the rays that you've got down there, part of the corona. I remember seeing something like that through the telescope. And
you can see it visually. You can see the corona visually. It's just the camera.
Yeah, it didn't have nearly the amount of detail.
Yeah.
When I remember seeing it, first time seeing it, it just kind of looked like, it almost had the look of a fried egg, the way the corona, the light of the corona just sort of spread out, and you had the moon in the center. All of that detail was there, but I don't know that I looked at it enough to start to pick some of that detail out with my eyes. And then I put it under a telescope and I started to see more detail, like the rays coming out, and saw some of the prominences there as well. Didn't look at it long enough because it took me too long to take the look through the telescope. The diamond phase was getting ready to start. So we pulled all our eyes away and said, cover your eyes, put your glasses on. We were trying not to get blinded when it moved beyond.
Yeah. So, I was in a rush this whole day because trying to get down there and all the traffic and everything. I finally got set up just like a half hour before
whole thing
totality, and
went.
I was taking exposures, making sure everything was working all right. Totality hit, and I was like, oh wow, look at that, and I was trying to take pictures, and I'm like, I don't see anything on the camera, but I want to look at. I realized that I forgot to take the solar filter off the camera for totality, so I was like trying to take exposures, and nothing was showing up.
You are not the first person to do that. So
Yeah, so halfway through, I was finally fixed that problem, and I was able to get one full set of exposures. And when the diamond ring hit, I fumbled with the exposures and the filter, and I didn't end up getting that. So I definitely think next time I want to try to fully automate a camera. They have software that'll fully take care of that.
For one of my cameras, EOS Backyard, I have an intervalometer that you can set up. You can put on the hot shoe and it'll do. You can set up the exposures and groups and all of that. I'll have to play around with that because
there's software called Eclipse Orchestrator.
Oh, cool.
It's keyed into the time code, and it will actually adjust your camera exposures to capture first contact, Bailey's beads, the diamond ring. It'll full HDR totality. It'll do it all.
That takes all the guesswork out of it. Set it up on the tripod, make sure it's tracking, and hook it to the computer and let it go. I might have to check it out. Eclipse Orchestrator.
Yeah, I've never tried it. I thought about it for this 2017 eclipse, and I never got around to it. But
I think you did fine with what you did.
It wouldn't be a star party unless we looked at something in space, right?
True.
So this is a live view. Oh, look at the clouds, just in time. This is a live view of the moon through my telescope. I got it set up outside. I was hoping to do a little bit of imaging tonight, but it looks like I won't be able to. But
yeah,
we can look at it close up.
Wax and Gibbous. Yesterday, Copernicus, I think, made its first appearance. And now it's growing larger.
There you go.
There's Copernicus. I had to learn a lot. We've got Rick Hill teaches a lot in his articles, his exploration of the moon, and so many craters that you can get the names for, and some of the information about just Copernicus, Tycho, the really bright one whose name escapes me, a fairly recent one to the left that's not quite in view yet.
Yeah, Aristarchus,
Aristarchus.
I might be pronouncing that wrong. But
no, I think that's the way I'd know to pronounce it, Aristarchus.
I always like this one. This is Schiller crater, shaped like a potato. Look at the wind.
Yeah.
So I was able to, like I said earlier, I had this stacking in the background because I was able to take a set of exposures earlier when the scene was pretty good. This is the view of the moon tonight through a red filter.
Uh-oh. We lost your audio a bit, but you've got something that looks an awful lot like Google Moon.
Yeah, this is the moon from tonight. So can you hear me?
Yeah, we can hear you good now.
So before I was not facing the microphone, sorry. Before the clouds came, before I started talking tonight, I took a set of exposures. So this is a video through the red filter of the moon tonight. And then this is sharpened and presented for your enjoyment. But the seeing was really good earlier, so I was able to get some pretty good details here.
Yeah, you've got the splash middle region of Copernicus.
Yeah, I always look for the if you can see these 4 craterlets in Plato, you're doing all right.
Yeah.
The 1, 2, 3, 4.
Yeah. Knowing that if we were standing there, that one craterlet would be big enough to swallow us.
Right. I think those are I would be lying if I said a number right now, but I think they're less than 10 kilometers across, these craterlets. I think they're just a
Yeah.
handful of kilometers across.
Yeah. That's still
I think,
still
I think you
bigger
can
than
see-
us.
I think you can see Aristarchus here.
Maybe
That is-
barely. I think it's just
That's
coming
it
into
there,
view.
isn't it?
Is that it? That looks like it. I know it's deep and it's like a very striking deep, and it's a fair, I guess it's fairly new compared with all the others. That may be, yeah, that may be it. Let me look. That.
All right, well, outside of that, I don't know how much time I've taken up, Scott, but I got some videos I can show, some solar, but I can easily let it go if I've hit my time. I feel like I've been talking for a while.
Well, let's look at the schedule here. We're running, quite a bit behind right now.
Okay.
So I know there's always more from the vast reaches. So, so
Well,
we'll have you
I
on.
appreciate you having me on again, Scott. If
Thank you, Jason.
anybody wants to see my stuff, yeah, you can find me under that
Vast
handle
reaches.
on.
Yeah,
on
I
major
posted
platforms.
a link to your website. So
Okay.
that's awesome. And a
Yeah.
beautiful eclipse shot. You might have mentioned which telescope you did that with. What could you?
That was with the camera lens. That was with the Sigma 150 to 600
Okay.
zoom lens and a Canon 6D.
60.
So I just
Yeah. So I
shot
happen
that.
to have the same equipment. The shots I took is with that same type of lens, except I don't know, Jason, if you've got the sport or the
No,
contemporary.
it's the contemporary.
Yep. I have the same lens. That's the one that I do most of my wildlife photography with. And I'm finding it's not bad as a lens for shooting at the sun or shooting at the moon. So
Yeah,
I may.
I've been pretty happy with it. I've shot things like ISS transits with it, and it's done
Cool.
it's done an impressive job. Seeing if I could pull one up real quick. Yeah, here's an example of a ISS transit with that
Oh,
lens.
there you go.
Not bad for a
Yeah,
it's
beautiful.
not
lens.
super expensive, but if it compared with the right the right camera, it zips into focus pretty quickly. And it's pretty sturdy.
Yeah, so this was just with a white light filter in front of the camera and
Yeah.
ripped off a couple exposures
Nice.
as quick as my camera would. But it only caught 3 frames. I mean, the 6D is not a fast camera, so it only caught it 3 frames on the surface.
Okay. All right. Well, thank you very much. Thank
Yeah,
you very
thank you.
much. Up next is Marcelo Souza. Marcelo has been on Global Star Party now many times, and he is the senior editor of Skies Up magazine. But he's preparing for an international aeronautics and astronautics event, and he'll tell you more about it. Marcelo, you want to come on to the program?
Hi,
There we go.
thank you very
Marcelo,
much,
thank
Scott,
you.
for the invitation. Thank you very
Thank
much
you.
to be here. Today I was talking with my students about something that before the pandemic, I did a lot of presentations about this theme that is, we are talking about elementary particles and also the fundamental particles. Right? And I will share here, try to make a free talk about this theme, because I think that is something that many people have doubts. And something that is important when we talk about elementary particles is this. This is one cartoon that I think that is fantastic about a physicist that works with particles. That he said that quarks, neutrinos, mesons, all those dumb particles you can't see. That's what drove me to drink. But now I can see them. I have so many particles today. No? Then who works with this? I worked with cosmology, and I have to study elementary particles. And something that's fantastic is here in Brazil, I don't know in other countries, no? When I talk with students from high school, and they are also the students that is studying physics and the engineering at the university in the first years about the structure of the atom, and they imagine ever, you have the the atomic nucleus composed by protons and neutrons. And the first question, I don't know why they didn't ask before, is if the electromagnetic force between protons is repulsive, how the protons are inside the atomic nucleus. It's something that in 1930, they begin to try to find a way to explain this. Then when they try to explain this now, they found two different kinds of force that now is the base of the physics. And who predicted first the existence of the pions that are responsible for this was Yukawa in 1935, and the pions were discovered in 1947 with the participation of the most famous Brazilian physicist, that is Cesar Lattes. He is so famous here in Brazil that the platform that we use to insert our curriculum here in Brazil has the name of the scientist, that is Cesar. In English, I think that is Cesar Lattes, that to say, but in Portuguese, it's Cesar Lattes, his name. He works in Bolivia. And also, when we go to these small worlds, we have something very strange that today everybody talk about this, that are the antiparticles that was proposed by Dirac, that appears as a solution of his equations, and the positron, that is the anti-electron, was discovered in 1932 by Anderson. And here you can see a photon that decays in an electron, and a positron that is an anti-electron that you can imagine like this. And you see that in the same magnetic fields, they go in different directions. They have a different charge from the electron. It has a positive charge. Now everybody talks about antiparticles, even in movies, and in many places. And also another strange particle was neutrino, that was proposed by Pauli to explain what's happening in the balance of energy in stars. And the Fermi called it neutrino, that gave the, and it was found the first time in 1956. Then you see when you go inside this small world, many things are different than we imagine. And something that is fantastic. Here, what happens when a positron and the electron, they meet, they disappear, and you have only energy here, and here is the positron. And here now is the structure of the matter, as we know. We have two kinds of the family of particles, that are the leptons and the hadrons. Leptons are the particles that don't have nothing inside. like electron, that is a fundamental particle, the neutrino, the muon. Then these are you have 6 kinds of leptons, and you have the hadrons that are particles that you have internal structure. They are composed by quarks. Then for us now, the proton and the neutron are not a fundamental particle. The fundamental particle in this structure are the quarks. Then, for example, a proton is composed by 3 kinds of quarks, and the neutron by 3 kinds of quarks, and the mesons, like the pi, they are composed by a quark and an antiquark. And I will show now how this is. Now, then, first I will talk about the hadrons, that are particles composed by quarks, and the force between the quarks is we call the strong nuclear force. And the residue, what you have from this force, is what makes inside the atom the protons have an attractive force between them. That is inside the atomic nucleus is more intense than the electromagnetic force that is repulsive. This is the reason that you have the protons inside the atomic nucleus. Then you have 3 kinds of hadrons, that is the baryons and the mesons. Baryons are like protons and neutrons that are composed by 3 quarks, and mesons, you have 1 quark and 1 antiquark, like the pions. And you have 6 kinds of leptons, that are the electrons, the taus, muons, and 3 kinds of neutrinos. The fundamental are the electrons. The most energetic are the taus. Then they come for the muons, and then for the electrons. And we have neutrinos associated with each one of them. We have the electron neutrinos, we have the tau neutrinos, and the muon neutrinos. Here. Then you have here the muon, that's more energetic than the decay in an electron. And when this happens, you have neutrinos and antineutrinos here. But it's not, sorry, they are in Portuguese, sorry, the presentation. Then you have 6 kinds of leptons. You have 3 kinds of families, different families, that are the electrons, the muons, and tau. Each one electron have a neutrino associated with him, that is electron neutrino, the same for the muon, the same for the tau. Then you have 6 kinds of leptons. Then for symmetry, it's necessary to have also 6 kinds of quarks. Then I'll not talk about this. And Gell-Mann proposed the name quark from a book of James Joyce. And inside the book, you have this phrase that 3 quarks for master mark. They means nothing. Depends. Then this is the name of these particles, quarks. And you have 6 kinds of quarks that you call flavors, different flavors. You have quark up, quark down, strange, charmed, top, and bottom. Then you'll see the symmetry. You have 6 kinds of leptons and 6 kinds of quarks. And these 12 fundamental particles are everything that we have in the universe are composed for these 12 fundamental particles. Something very different than you can imagine. And then here you have the charge of a quark, that it's part of the charge that you know, the electron charge, for example, 2/3 of the electron charge, minus 1/3 of the electron charge. And these are, you see here that have different kinds of energy. The most energetic particles are the top and the bottom. Then you imagine that they are responsible for the structure of particles when you have more energy in the universe, in the beginning of the universe, for example. Then you can something to illustrate this in sizes. If you can imagine sizes like we don't have you can't see like this, but it's only an idea. Then if you imagine a size for the quark, it's something less than 10 minus 18 meters. Something like this. If you can measure size. Then you have two kinds of
Incredibly
size.
tiny.
It's something that here is only to have idea. Here you have the flavors and the charge for each quark. And each quark has an anti-quark. You have the up and anti-up, down, anti-down, charm, anti-charm, strange, anti-strange, top, anti-top. Here are the quarks. And here are the flavors. You have each one, you have different one. But you have something different also. That they have a characteristic that is like the charge for the particles that you have. That different, you have the charge here, but the quarks has another characteristic. Here you have how is a neutron, a proton. A neutron is composed by a quark up and two quarks down. And the proton is composed by a quark down and two quarks up. Then this is the basic structure of the protons and the neutrons until today. Maybe we're trying to find something that's most fundamental than this one. And also, these quarks have charge, and also now he has another characteristic that is the color. We have three different colors for each quark. It's not colors like we imagine. It's the name that they use for different properties of these quarks. Then you have red, blue, and green. And this is something that's mnemonic. I don't know if it's correct word in English, because you need to remember that all the particles that are composed by quarks need to be white, because the red, blue, and green as lights, they turn in the white light. Then, and also have the anti-red, anti-blue, and anti-green. Then you have colors we have quarks and the anti-quarks with different kinds of charge and also different kinds of colors. Then something very different than we imagine. Here you see the three quarks that the proton are composed. They have different colors. Then we can imagine that is like white. And the same thing happens with mesons like this. Then I will not go more. You have antiquarks that carry a color, an anticolor, and the gluons that is responsible for the interaction. The quarks change the colors. These are responsible for the force between the quarks. And here you see the protons, neutron. That's the quark force of color. And the residual interaction between the quarks that are responsible to make the protons be together, be near inside the atomic nucleus. But this is part of what is responsible for this force between the protons and neutrons inside the atomic nucleus is the strong nuclear force between the quarks, and the residual force that is responsible to make the protons be together. Then we have four fundamental interactions in the universe and fundamental force: the gravity, the electromagnetic, that explains everything that you have here in our world here. But when you go inside the atomic nucleus, we have two new forces that are the strong nuclear force and the weak nuclear force. These four interactions are the fundamental interactions that we use to explain everything you see in the universe. You see, like the residual force, you have the electromagnetic force, residual electromagnetic force that makes the atoms to be in molecules. Is the same what happens inside the nucleus, the atomic nucleus. And something that's very strange when you have, you try to find an isolated quark, you need so many energy to do this, that is not possible. You have the energy makes that you have two pairs of quarks, two new pairs of quarks. You didn't find an isolated quark until now. At least they are in pairs. Then this is the important question now when you find a particle. Excuse me, are you a fundamental particle? This is the question that all the physicists that work with elementary particles ask nowadays. And this is the structure of the universe you have. You have these 12 kinds of fundamental particles here. The quarks, you have 6 kinds of quarks and 6 kinds of leptons. And here you see, you have 3 kinds of families that can imagine like this, generation of matter. The first one, o quark up, quark down, the electron and the neutrino of the electron neutrino are responsible for the visible matter that you have in the universe. When you have more energies, you have the second line here, that's the quark charm strength, the mu neutrino, the mu neutrino, and the mu. And the most energetic fundamental particles are the quark top, bottom, neutrino, and tau. And these are responsible for everything that you imagine that we can find in the universe. These are the theory that you have here of elementary particles, the fundamental particles. Okay, I try to make a free talk about this. I don't know if I make it's a very quick presentation, and
Yes.
I try to show only that when now we're talking universe, I have many things different than can imagine that is responsible to our models to explain the matter as we see and we measure in the universe. Okay. Thank you, Scott.
Thank you so much. Thank you, Marcelo. Wonderful. You know, being that this is, of course, all invisible to our everyday experience, you know, the tiniest levels of the universe are really, really strange, you know, and you know, understanding you know, the physics involved in this is also foreign to most of us. So, but needless to say, it is still all part of our universe, and the largest things in the universe are built up from these things. So there we are, including ourselves. So
science is fantastic. It's the most powerful tool that the human produces until now. That is responsible for all technology that you have nowadays.
Thank you for the quick lesson, Marcelo.
My pleasure. Thank you for the invitation.
Talk just briefly about your event that you have coming up.
Yes, next week on April 22 and 23, we are organizing our international meeting of astronomy and the astronauts. It's the 14th edition, and Scott Roberts will be one of the invited speakers. You have the participation of Dr. Levy, Cesar, that's an astrophotographer from Turkey. You have also a guy from Cameroon that will talk what they are doing in his country, in Africa. You have many Brazilians that work with cosmology and astrophotography that will be involved. And this is the event that's organized to motivate the students here and in other places here in Brazil to be involved with astronomy. It's a free event for everybody, and part of the event will be online. It will be a hybrid event. We have on April 22, we'll be here in a theater in our city. I hope with a big public. I hope so that we can find. You have 700 seats in the theater. Then I hope you have. And on April 23 will be an online event.
Thank you very
Everybody wants
much.
to join will be very
posted a
welcome.
link to your Facebook page for the event, and so tune
thank
in
you
if
very
you
much.
can. Wonderful.
Thank
Thank
you.
you. Thank you.
Thank you. My pleasure. Thank you for the invitation.
Thank you very much. Okay, so up next is Cesar Brollo. And so Cesar has been away for a little while, but he went to a fantastic star party and he's here to tell us all about it.
Yes. Can you hear me? Because I don't
loud
know.
and clear.
Thank you. Okay. Well, yes, Scott, I returned to the Star Party Valle Grande in Mendoza, in San Rafael, Mendoza. It's a star party that I'll be being the partner of Jaime Garcia from the Instituto Copérnico, that he live in Rama Caída, that is an area of San Rafael, Mendoza. And we made together a star party that it's a meet of a lot of directors and presidents of different astronomy club associations, nor people that is only amateur, but this time as was this the first meet in person after the pandemic, was really amazing, and we was only near to 70 people, but was great because we can watch to each one again in person, to meet the people, touch the people, you know. This is something, so yes, without a screen. It's really magic. Oh, it's you, real. Yeah. And well, it was really a nice meet. We had a beautiful night, beautiful people that really we each other to talk a lot, you know. The sensation to be in the place to talk in a real life situation.
Big difference.
Yes, absolutely. And for me was a shock because I forget the quality of the skies in San Rafael, because it's not in the middle of the mountain. It's not. It's great because maybe if you need something, you can go to the city, and you have a city of 200,000 people. But I found that since the city have all LED illuminations, only they have, first of all, we are at maybe 20 kilometers from the city. And the city, I don't know why, don't work over the sky like you can suppose. And you are in a safe area. If you need something, you know, about healthy, or you have a big city really near, only 15, 20 minutes. You have a lot of area of vineyards in the area of the Valle. Jaime Garcia is a great producer, and he produced their own wine, excellent wine. He knows every time more about how to work in wine, and it's a process that, because he's astronomer, it's very interesting that Jaime, of course, that in 2 weeks more, Jaime is coming to the Global Star Party to talk, because he's a member of the AIVSO. He was 50 years watching and working for the ABSO. The ABSO is a very important part of our meeting. In 2010, we meet together with the spring meeting of the ABSO and our autumn star party in April. Really well. We had a lot of fun. I have a lot of pictures to share with the audience. Okay. I hope that you can, enjoy the pictures. Sure. Let me. You can see it's not a presentation. Yes. If not, it's the photo viewer of. Well, this is Star Party Valle Grande. April 22 was the 1, 2, 3 April, last 2 weeks ago. This is the Instituto Copérnico. Is an instituto that Jaime Garcia founded. Next year, it will be the 50th anniversary of Instituto Copérnico, and we, of course, we are making a bigger star party. Well, here is the picture that I took. Really, the first thing that I remember, I thought in Adrian Bradley, our friend. I say, right. Because I was working in the, that in this star party, I was all time working, thinking if the connection for the telescopes or, but I took some pictures quickly, and all pictures work properly without make nothing. Normally the dry, the level of humidity is only 15%. And this is why the place is beautiful to take pictures. This is part of the roof of the hotel. Mm-hmm. Here is a light. These lights are only the lights that are in the how we say, dique dam, la represa. Because it's the only lights in the area where you can find, but we turn off the completely system of illumination of the hotel. All completely is turned off in the hotel and in the area of the parks. Well, you can see that in these pictures, you can see the Magellanic large cloud. It's another picture that I took. I took only 3 or 4 pictures. Here you can see a much better quality. This is a picture of Mariana Massino. She took this picture, and only the light is only the light of, maybe we can't see these trees in the night, but you have the reflection maybe of some lines in the distance, and it's a beautiful combination where you can see the large Magellanic cloud. This is another picture that I took, only 30 seconds. This is the area of Cruz del Sur, Southern Cross. Well, I don't remember
that is an amazing Milky Way.
Saco de Carbón is in Spanish, but Eta Carina Nebula, yes. Cox. Well, I don't remember. Ever I forget the name in English. Here is another part. Is the roof where we make observations. Normally here we make all that is astrophotography because it's more easy to connect. Connect your computers, your telescopes, and in the grass of the park you have all to make only observations, especially with Dobsonians, or if you have a small mount with your own batteries and a camera, it's much better go to the grass. Another picture that I took, but without the quality of Adrian Bradley, of course. I think all time I think
you're gonna have to invite Adrian.
Come on, yes, Adrian need to go. Yes, need to come here and enjoy this. This is the center of the Milky Way, and it's only at 45 degrees. Man. Maybe 3 a.m. in the morning. This is a picture of Fernando Ricardini. Fernando took the area of Eta Carina Nebula in 30 exposures of 2 minutes each. Another picture, well, this is in the day, before the night, of course. We prepare all telescope that was for all people that say, okay, I can make astrophotography. And here, well, Cassebrans, Richie Gretier in another part. Here you can see the we prepare 3 or 4 National Geographic that we carry to the event only for visual. We enjoy a lot this telescope to use in the night in these skies. You know, the Explore Scientific National Geographic telescopes.
Thank you.
Yeah, you're welcome. But was amazing. Really, we enjoy a lot only for visual. We use it a lot, this telescope. Of course that we use Dobsonians too, and a lot of different telescopes to take pictures or only watch the sky, of course.
Yeah, it looks like a very comfortable and beautiful place to have a star party.
Yes, absolutely, because you can go to your room and return to use your telescope, or go inside of the hotel without work, nothing, trip, nothing. Is and you have your room very comfortable and cozy, and it's it's very, sometimes you go to the star parties with a tent and say, okay, yeah, I suffer a lot, but I love, of course, for me, it's beautiful. Well, here they have a camp, special camp very near in the same complex, if some people like to go in a tent. But all people choose the rooms, of course, and it's wonderful to eat. And it's the joke that we talk about this. It's an event, meeting of astronomy with the G of gastronomy. Gastronomy, or gastronomía in Spanish, is all about food. It's the business of food. You talk gastronomía. Only the G is different between the astronomía and the G. Yes, it's amazing. Well, this guy making something similar to be a photographer, but no. And this is why this is the most important clouds. Yes, of course that is science. This is only to make spectrometry. And this is sure, of course. Right. Yeah, the chorizos. The chorizos is chorizos at 3 p.m. At 3 a.m. Sorry.
3 a.m. chorizos.
At 3 a.m. chorizos. Yes, it's like a sandwich, choripanes. This year, my partner in this business that is a professional astronomer, is Eric Gonzalez. You know, to Eric Gonzalez,
right?
He couldn't went to the star party, and I carry this with a maestro, musician specialist, and amateur astronomer that is Lucas Rocco, and he helped me to make a good quality asado with chorizos, choripanes, you know. But it's only science, of course.
Of course.
Only, of course. This is a beautiful picture of Centaurus, a galaxy that took Fernando Riccardini. I think that Fernando Riccardini is the man that the amateur astronomer that more pictures by telescope took. And he, you know, sometimes you have the people that work in the star party and say, okay, I really take pictures and don't only speak with the people or take pictures of the sky with the camera only, because I'm sometimes I work, but I talk a lot with the friends, and you know, I spend all my time talking in the night, but we really have so huge fun, you know, you understand me completely. Sometimes you say, oh, you took pictures. Yes, I'm not. I have the telescope, but I talk a lot with other people, you know. This is the star that the star parties really are. But
these are the audience.
Yeah.
This.
Yeah.
Jeff Wise says, I see the chorizo emission line. Diego Jaimez, he said, I participated in the star party Valle, Grande,
Diego.
Souza, Argentina. Cesar, no me invito a la. I can't even pronounce
No
this.
me invito. Yes, he told that many people go to sleep, or because we call to the old people, come on, 3 a.m. chorizos. Yes. Next year, Diego and another ones be.
You need to set an alarm clock, right?
Yes,
for the 3 a.m. chorizos,
yes,
right?
Yes, yes. Next year, I'll put in the official program, but you know, it's something clandestine. Yes, I know, but the people.
Sebastian Otero said, you ate all the chorizos without sharing them.
Yeah, yes, it's very important. Sebastian Otero. No. Prepare yourselves to read the comments, because I talk about that, guys. I present your pictures tonight in the global safari.
Yeah. So now he's sharing.
Yes, and they are talking. Yes, I know that if you. Yes, I told them to say, if you need to talk something, you can put comments in the web. No problem.
And they are.
Yes, of course.
Comments.
Yes.
Mostly about not being invited.
Don't be afraid about the chorizos, because next year you can enjoy again. Yeah. Yes, sure. And this is Sebastian Otero talking about, because he is a member of the APSO. He's Jaime Garcia and Sebastian Otero. And this is part of the talks that we will really enjoy the talks, because and Sebastian is a genius to explain, and really we are happy to have in a global star party to Sebastian, because he's a great professional about variable stars. Sorry.
Sure.
Really, and he's really very fun about how it's playing, and it is very important too. And he's a bird watcher now. It's a genius about bird watching, Sebastian. Here, well, I remember the names. Martín Telechea, Santiago Mayese, Pablo Barrios, me, Rafael Girola, and Sebastián Otero. And here is, well, I don't remember the name now, but this is my friend too. It's from Catamarca. I remember later the name. Well, here it's me with Santiago, with Alejandro Varelli. We was talking about optics in astronomy, especially about the beliefs about how telescope, was more about belief that the people believe about optics in astronomy. For example, Scott, when you receive the comments from the people say, okay, I have something to clean in my optics because this can be in my pictures. We talk about this.
Right. Oh yeah, like a little speck of dust being on the lens or something. They
yes, it's something that you can
harm.
Yes, absolutely, absolutely.
Right.
Yes,
Which
yes,
is absolutely not true, but.
And was a very nice thing to share to the people, and the people, ask us about this belief or something that all people say, yes, it's real, I believe that. Very, very nice. Myths and another surprise about optics. This was all this is the team of Bella Vista al Cosmos that are working. Well, I'm working with them about the restoration of the observatory, solar observatory in San Miguel. Here is Jaime Garcia in his talk about his 50 years watching variable star. This was very interesting. Wow. For me, it was a surprise. I said, Jaime, it's incredible. 50 years was a talk, because we was talking, about organization. And when I was in his talk about was amazing. Yeah, really. Claudio Martinez talked about astroturismo, a business for that the people can carry or can make for carry people and go to see the stars. It's something that is in Argentina and Chile, well, everywhere the people go to see the stars and talk about the myths. It's very interesting. And it's a growing business in Argentina, because we have a lot of skies really dark. Here, well, more talks. I was really interested, Sebastián Otero, about variable stars. Well, I talk about when it started the meeting. That was talking about with Jaime Garcia. Jaime Garcia is going to appear in Global Safari. I told him that to go to be in Global Safari. More in the night, the hotel, a view of the hotel.
Very nice.
This is our classical music presentation. Lucas Rocco is the director for all that of this and the sound in the mid, and he's a musician, excellent, and he was my partner to make the choripanes. That was very important because he know the best chorizos, or the best breed, with a better quality, because it's a local enthusiasm and really an excellent musician. Solar observations, of course.
Nice.
This guy is my friend Gabriel Bengochea. Gabriel is astrophysics. It's a genius about to explain that professionals came to our safari. Really, we enjoy their talks. Well, it's a great friend. Gabriel is the creator of the clandestine talks in the night when the people feel something freeze about the the weather, you feel cold, you can go to the clandestine talks. That is a tradition in our third party inside the lobby, and you talking the entire night about physics and astronomy. It's very, very nice. And the people carry a coffee, enjoy the talk, and return to their telescope. It's very nice.
Very nice.
Yeah, we really enjoyed that. A lot of talk. Sorry, Federico Garcia, the Jaime Garcia sons. It's actually a professional astronomer too. He was working in Holland and France. He actually is working in X-rays, investigation, research. It's a great professional. But of course, Gabriel Bengochea, it's a very important part of the star party. This is the area in the where what is the dam, the lago, the lagoon. Sorry, today my English is impossible. Many weeks that I was out of the global star party, and I lost completely my English. Well,
no problem.
Yeah. And the area is beautiful to visit in the day. This is at only maybe no more than 20 kilometers from the place where we are. More pictures. Sorry that I don't remember, maybe in the comments, I don't remember if this picture was taken by Pablo Barrios, maybe. If I hope that somebody comment in the about this. Jose Luis Sanchez with a cell phone, I think.
Wow.
I think that this is all with cell phone.
Wow.
Another pictures of the people.
Mm-hmm.
Jose Luis Sanchez too. Jose Luis Sanchez is the partner of Victor Busso. Victor Busso discovered the supernova increasing in the first moments of the taking Bragg. Talking about, for me, it's impossible to explain, but was really, really important. I don't know who found the birds in the night. I don't know if someone.
That's cool.
Please, I don't know if somebody.
Milky Way with birds.
Yeah, yes, it's incredible. Many of these pictures I know that are with cell phone.
Mm-hmm.
Nina from Patagonia Sky took a lot of pictures, and she was working, with the tripod, the camera, and she took a lot of pictures, very, very, very beautiful pictures. It's me, Jaime Garcia. Well, at this time, I forget the names, Santiago Mayese, Pablo Fiselev, but sorry, that, yeah. Earlier, I remember all names. Now, well, sorry guys. Yeah, the another part of of the telescopes.
That's a really cool picture.
Yeah, here you have boats for visual Nat Geo. I enjoy a lot. I found a lot of asterism that I never. My friend Martin Telechea is a really, really smart guy to say. With nothing, he found a lot of things he knows, and he remember a lot of Messier objects and asterism. He have their own go-to in his brain. Yes, it's the guy that say, okay, we can found here, but a little more to the right, and say, you found it, incredible. Yeah. Yes, people enjoying the third party. Jaime Garcia, my friend, Nina from the owner of the pictures. I don't know if there are pictures from Sebastian Otero, because he's a bird watching, and Nina from Patagonia Sky, sorry.
Nice.
Yes, it's our tradition. He is the man of the go-to in his brain, Sebastian Martín Telechea. Beautiful. Here you have the river. The river. It's very, very near to the hotel. Only 100 meters, no more. And you can go to take pictures. It is special for Adrian. It's a special place to Adrian. We lost to Adrian in this area. Yeah, yes. More birds, you know.
This is cool.
Javier, yes. I have a lagoon in my memory with the name. Well, if Javier tell me yes, no,
you don't remember the names, you remember the faces, you know. So
no, but it's terrible because it's a friend. No, I forget totally the. No, sorry, it's terrible.
It'll come to you. Yes.
It's a place that is fun because you have a lot of things to if you go inside the hotel, you have a lot of different landscapes. We now go outside the hotel. You have in the park, you have all completely, you know, the different places to make composition of the sky. Right. And this is that the people make in our parties in the day, go to drink mate, yes, and talk by the river that is near to the hotel.
Beautiful.
Cross. I think that is a picture of Pablo Barrios, and this one is from Javier with the cell phone and the filter, a telescope with a filter of Alejandro Varelli, I think. Beautiful place. This is another picture of Diego. That Diego is comment now. I think that this is the part of the conjunction, because it was the conjunction between Mars and Jupiter. This is, I think, this is a picture of Rafael Girola. Martín Telechea, Santiago Mayese, Pablo Barrios, me, Rafael Girola. Pardon, I'm sorry that I can't believe that I can't believe my friend from Catamarca, this Catamarca Astronomy, work a lot. He's a genius of to make astronomy and something in learning education for the kids especially. This is a picture of that took Pablo Barrios.
Wow.
Another picture of the canyon, the area where it's very near to the Valle Grande. Yes, it's Valle Grande. It's the same place. It's a place where you can go to visit.
And how far is the drive from the hotel to this area?
Sorry, how many kilometers or?
Yeah.
It's in the same. For example, we was in the entrance of the canyon. If you can go to the west, the canyon is going to hide the walls. And when you found the dam, you can see from another side, you can see the lake. It's no more that I think that it's no more than 10 or 20 kilometers. It's very,
Very close. Yeah.
very close. Yes, it's in the same day. In 2 hours, you can visit the complete area. But this is very, very tall. And you have a little ship, a boat that you can get traveling. Miguel, no, it's not Miguel. Well, I think I can't believe that they forgot.
Somebody was writing Miguel and Diego.
Yes, it's Miguel, but Diego. I think if Diego comment that the name can help me. Well, and this is
Miguel.
We are
Miguel
Magakian. Miguel Magakian.
Yes.
Yes, because he have a Armenian family. Yeah, yes, absolutely. Miguel is a genius. I need to go to Catamarca because it's an amazing place too. And well, here we are all together, and you know the globe, the picture of the globe.
Yeah.
We enjoy a lot, and of course, all one are invited, especially in the people from the Global Star Party. We are awaiting you for next year in April. We can get a lot of. We are going to make a bigger Star Party because this year was only for start before the pandemic situation, and next year we can return to our normal numbers over 100 people. In Argentina is a great number for we can't compare for another Star Parties, but we are really people that went with their telescope. Really, they're really interested in enjoy astronomy, and this is beautiful. And well, this is my presentation about the Star Party.
Thank you,
Yeah.
Cesar. You'll have to give some more information about the next year's Star Party. I don't know if the dates are already. Do you already know the dates for next year?
I don't know because we need to talk. Normally, we have the time in maybe this year in October. We have ready the exactly days because we take the entire hotel for us. Because if not, this is something that first of all we need the hotel entirely for us. Because if you have another people in the hotel, it's really people suffer us, and it's not so good. But when we have the time from the hotel, we say, okay, you know, it's not a full moon, of course. It's a new moon, and normally it's in April because it's a great time for have a great situation of weather. We had an excellent weather, very, very dry, very it's very important have first of all
you can see the transparency of the sky from the photographs, so it's gonna
it's very easy, and
viewing.
especially doing observations where you have a great difference with the another skies. We have in our farm area in Buenos Aires very dark skies, but the problem is that many times the humid make a scattering, and you have the Milky Way is not so bright.
That's the problem I have in Arkansas many times. You know, it can be very, very dark.
But you have 60% of humid. It's not too much, but you have absorption of light.
That's right. That's absolutely right. So, yeah, only occasionally we get really clear, transparent skies. You know, and those we really treasure here in Arkansas. So, which is why we are going down to Texas for the eclipses, and so, because we have a better chance for transparent sky down there, clear skies.
Yes.
Yeah.
Yes, it's very
Well, we'll have to
important.
learn more about it. Certainly I want to get down to Argentina for one reason or another to come and see you, Cesar, and maybe we can get Maxi and all of our friends together at some event. That would be great. So
Yeah, yes. We needed to Maxi in this star party. Next year, I told to Maxi that he really need to go to San Rafael Mendoza.
yes, sounds great. All right. Well, thank you very much, Cesar.
It's an invitation for everyone in the room.
Yeah, we're going to bring
you're
up.
welcome.
Yeah, everybody can come, right? That's right.
Yeah.
That's right. Now,
Okay.
for us vegetarians, do they have vegetarian chorizo in Argentina or no?
It's something like to see an UFO or I don't know. I never seen that.
Right.
Okay. No, I don't know.
Okay.
Well, we can make something for everyone. Yes, no problem. We can make a tofu in
can
the
make it, sure.
barbecue no, but I make a barbecue with vegetables very good. If some people told me, yes, I need another thing, I am vegetarian. Yes, I can make that for the people that don't eat meat. Absolutely.
Great.
Yeah.
Awesome.
Yeah.
Awesome.
Yeah.
So, Maxi, are you ready to come on tonight? Maybe he's getting a chorizo himself.
Yes, it's the time with
It
Matt.
is the time.
We are
I
waiting
see,
to.
I see Maxi's there, but
Maxi.
come on.
Maxi, come on, Maxi. Yeah, yeah. Yeah, Maxi.
Maybe he had to be called away. I'm not sure.
No, yes, sometimes when you are awaiting and you say,
I
yes,
know.
I can go to
I can
make
go do
something.
something, right?
Yeah, yes, but it's something that for everyone in our third parties. But this is incredible that we have 90 third parties.
I know. We've done 90 star parties. You've been on many, many of them. I think, with the exception of the first few, I think you've been on almost all of them, Cesar.
Yes,
So,
and the last ones, but maybe no more, 2 or 3. Yeah.
right?
Yes, I have a record.
You do? Oh, do you really? You keeping a book?
Yeah, yes,
Yeah.
absolutely.
So let's see if I can find Maxi here.
Yeah, yes.
Let's see. I'm calling Maxi.
Excellent. Yes, I I sent him, and yes, excellent idea. Yes, it's a great thing of global third party. The people knows that we are really, and
It's really
yeah.
live.
Yes, and Scott, it's in our after parties. I remember the day that we finished the talk at 4 a.m. It's the same that in real
I
estate
know,
parties.
it's very late.
Yeah, yeah. No,
Yeah.
I know.
Oh, no Maxi. No Maxi.
Scott,
Well-
you can go to the NIEF, or you went to the NF. Sorry, it's NIEF, the NIEF in New York.
NIEF. No, we did
NIEF,
not.
sorry, NIEF is NIEF.
Did not occur this year because they closed it because of the
Really?
pandemic. Well,
No,
it went
I
this
can't
way.
believe.
Okay, they had gotten approval to actually operate the NIEF event at the auditorium where they normally go, but because it's a very international type of event, so you have a lot of international vendors that show up for this. Celestron had decided to not come, okay, because it was still kind of early. We were seeing a spike in COVID cases and this kind of thing. So they decided, let's play it safe. And there was a couple others that decided to say, let's play it safe as
They
well.
say no. Oh my God.
Yeah. And so they just go,
At
look,
last-
a
at last
number of
minute.
these vendors cannot come or have decided not to come. And so, they felt that they made the right decision, and the people, there's Maxi.
Maxi, we're waiting
because there was
you.
not enough participants, they decided not to have it this year and to do it next year. So,
but this is very bad for the smaller, small expositors that they lost the opportunity for show their equipment.
Oh yeah.
I think that sometimes, I hope that next year, and I very interested in visit you, and of course I can offer me to work free and talk with the people in the Explore Scientific stand. If Maxi say yes, we can carry to Maxi too.
Yes, I agree.
Yes, Maxi.
Yes.
Yes, Maxi is no
So,
problem.
Here, I'm going to post something in the, this is from Diego, and he's writing to you, Cesar, so I put it in the chat.
Gracias, César.
Yes.
Nos vemos el año que viene en la próxima Star Party 50 aniversario de Copa.
Yeah, of course. Yes. Diego, I have a picture of Diego working. He's a teacher, and really he's a great and young amateur astronomer and educator. It's really, yes. We can invite him if he taught. I think that he taught in English. I don't know, but I never told him about. But it's a great education. Great people, really.
Awesome.
Yeah.
All right, well, Maxi, you've got the stage here, so we're going to turn this over to you. But
Yes,
thank you for coming on.
No, thank you. Sorry if I didn't answer. I was.
No, we figured you were getting a chorizo or something, so.
No, milanesa.
Milanesas, it's another kind of. Yeah.
Yes, I know.
It's beef with bread fried, and and with a potato.
Braided meat is in English. I don't know. Braided meat, or maybe I don't know.
Milanesa.
But exists in United States. Yes.
So, well, thank you, Scott, for inviting me. I was enjoy the Ghost Party where I could get and hear. Well, the last week I was doing some live views from my home, and I left my gear taking pictures almost to 4 a.m. And I remember wake up to get all inside, but I saw the great conjunction of Saturn and Mars nearby, and of course Venus, and it was pretty amazing.
Yeah.
So let's close this. Okay, let me share my screen. Okay. So I was capturing last week some deep sky objects that I was basically pointed and doing maybe pictures of 1 hour or a couple more. For example, we have here this, you can see here's a star, but behind of this star is nebulosity. Let me stretch it. This is the butterfly nebula. I think that is called in stellarium.
Oh wow.
This is only the stacked version because I didn't process this. You can see I have black places and bright in places, but I have to clear this up. but I think it was almost of 1 hour. But this nebulosity reminds me the Carina Nebula, because you have the Eta Carina star illuminating all the nebulosity, and but this is a lonely nebula, looks like. But here we have a galaxy. It's pretty far away here. There's another one, small. So then I went to NGC 4945, and this is what I get. This is the final processing. Let me put it more.
Oh, wow. Now, which galaxy is this?
This is NGC 4945.
49.
Is in Centaurus, nearby the Omega Centauri and Centaurus A. This galaxy, you can watch it with telescopes, and it's a really good place to take pictures. Well, we have here another kind of galaxies really far away. Here there's another one. Here's another one. And here behind this star, we have this one. It looks like the Large Magellanic Cloud mostly, but all these objects, I think they are a PGC catalog. But nearby this galaxy, there's another one. It's a lenticular galaxy. It's more brightness, but it doesn't have too much shape like this one. You have here the core, the clouds, the stars, and the dust. This is an amazing place to take pictures. I think a couple weeks ago, the APOD of NASA published one of these plays. Of course, doesn't mind, but it was amazing too. So then I also do this place. This is the Dragons of Era, or Dragones de Ara. This is in the Ara constellation, and well, here we have a lot of stars and nebulosity. But of course, this is a good place to take pictures in narrow band filters, but I don't have it. I only do color. Well, I have a color camera, but I hope one day maybe I can go there. I think I had to reprocess this because I think I went too far with the colors, and you know,
I like
the
it.
shape is. I like it too, but there's something that I don't feel it matches. I don't know what, but this is another phase of do astrophotography, you know. And sometimes you ask yourself, this is what it looks like, or this is I did bad lights or bad soaps, or maybe the calibration it wasn't good, and all those, and well, the processing it wasn't good, and all that things makes you reprocess and take again and practicing again and everything. And
now you can see some of the craziness of being an astrophotographer.
Exactly.
They're never satisfied. They always want to do better, which is what drives them. You know, Maxi, earlier David Eicher showed your Omega Centauri image. That globular cluster is so beautiful. David, if you follow him on Facebook, you'll notice that he shows really only some of the finest astrophotography made. So for him to stop his program and to show your globular star cluster image is quite a statement, I think. So And it was beautiful. It was a beautiful image.
Thank you. And thank you, David, for sharing here in the GSP. Well, it was, I sent it to all of you here in the GSP for a little gift because David Levy did a poem of this global cluster, and of course it was like, oh, let's put it together at the same
Sure.
time. So, well, the another object that I did, it was nearby the Carina Nebula, but this is an open cluster. This is a really good one. There's a lot of stars. When you see it through the telescope here, it's amazing to watch all the shining stars
Like
bubbling, and
sapphires.
yeah, and the background, there's a lot of stars. It looks like M7 global cluster, but in this case, this place calls yes, NGC 3532. This is a single picture, and the final result is this. I think it was only 1 hour because there are stars that are really brighting, but this is a really good open cluster to capture, to watch through telescope if you have a Dobsonian, if you have a good, even with small telescope refractors, and well, I use sometimes my Maxi top, and it fits really good here, and of course it's amazing to watch it. So a couple of days ago, I went with my girlfriend to Alberti to spend some in Sunday. No, sorry, it was the Saturday afternoon, and we've been. I did some pictures like Adrian does. I was taking pictures to birds, paradise. In this case, it was the sun behind the tree. Of course, my dog Sophie.
Hey, Sophie.
La Chofi. And of course, I was taking pictures to some pigeons. We have autumn's leaves or fall leaves. It's getting yellow, and this is without processing. These are the raw files. But what I did also, I was trying to capture, for example, we have the moon, and I think it was a venteveo. It's a bird that sings pretty loud. I think what it was, what I processed. I think it was this, or not. No, this is the moon. Another the moon. Well, I was manually trying to capture some birds, and here, this is one. We have the venteveo. I don't know if you in the United States have this bird. It's in everywhere here, and it's the sings of this bird is particularly like the name venteveo, something like that.
It's a beautiful shot. I love that with the moon.
Yeah, of course, the moon will be out of focus because the bird on the tree was nearby me. This is with the 270 millimeters lens and the Nikon. And of course, I did this with the moon. I posted on my Instagram page. Here's the blurred leaves, but get focused to the moon, and to do some kind of autumn pictures from here. And of course, I have some trees to the west. We can see people, the shadow of people there, and the sun going down through these trees. I was shooting this place. There was people playing football, soccer, and they are passing by. But you know, it was pretty good to capture this.
It's cool, like a Stonehenge.
Yeah, but with trees.
With trees.
And
Treehenge.
yes, I did. This is almost
beautiful, Maxi.
Yeah, it
It's
is.
really amazing, really.
This
is why we need to have you next year in our star party.
That's right, Maxi.
You can make magic, Maxi. Wow, look that. Maybe you get a green
flash?
Green flash, yeah. I think the same. Yeah. Yeah, sure. Come on.
And well, thank you, Cesar. Well, here is going down pretty low, and I think in this one I up again. You can see this tree and some crops on the field, because this is in the border of Alberti. This is a really good place to be, because it has a lake, also parrillas, place to. It's a good part. Oh, here's Sophie again.
Sophie again. Sophie's sleeping in your bed.
Right now, it's en la cucha.
La cucha, really? I can't believe that. No.
Yeah.
Your fiancé get the permission for Sophie. I know. Yeah.
Well, here's some venteveos, but
beautiful.
This is not grass. This is the lake, and it's full of this plant that floats in the water.
Yeah.
Oh, wow.
And these birds go, well, here's the bottle, that's a shame, but these birds goes to here and play and sit. And I think I shot this one here. There's another one.
Yeah, you'll have to also come on out. We have a number of amateur astronomers that are also making nice photographs of birds.
Yeah.
So we'll have to have
a lot
about that.
Well, Sebastián Otero, it's a variable star observers and a great bird watcher.
It's a parrot, right?
Yeah.
We have parrots, los loritos.
Parrots. Yeah. It's a problem. No.
It's a problem. They're loud.
Yeah. Huh? Yes, a lot. Yes.
Mm-hmm.
They're everywhere.
Yeah.
Yes. Good.
So, well, he's my girlfriend with Sophie playing with a stick.
So let me ask you guys something. Is it legal to buy a parrot in Argentina? Can you buy
not this kind of parrot, because no, anybody love this parrot because it's a huge number, but it's a plague. But the another ones from the north are completely illegal. Absolutely, illegal. Completely. Yes, from the rainforest, parrots are completely illegal.
Yeah,
all kind of and really it's incredible that here the controls are very, very exhaustive, because existed a lot of a huge illegal commerce in the past, but now is really, but first of all, I think that if you carry a beer, exotic beer to your home, your kids tell you why, because the education today about animals, about the extinction of the species, or I think that the people watch in a very, very bad way, have a couch, jaula. I forget the name of jaula, Maxi, in English.
The cage.
The cage. A cage with birds.
A bird
I
cage,
remember,
yes.
today is few only, I don't know if exists people with birds in a cage, because in the past, my grandfathers have a big cage with a lot of different birds, because it was normal. But today, I think that today is something that all comers of birds and actually the exotic species, I think that is something that is very bad, and especially the kids hate this. It's incredible, like and it's great because
that's good. That's good.
It's good, yes, but everywhere, yes.
And so
because
we'll inherit all that we did, and good and bad.
Don't have more sense in today, because you can get the camera and
Here in we have what we call like a grandma, but it wasn't my grandma. That she lived in beside of my square, and she has a parrot, but she doesn't have it in a cage. It was in el aro,
absolutely
in a ring that the parrot lives
and talk,
yes,
and talk explicit lyrics. Lyrics, yes, this was the best. Yes, if you in the past, yes, Scott, but this was different because it was a local parrot from the Pampas, the same that, and you have you can, yes, in the past, yes, like grandmothers or they have, yes, and the most funny thing, and in the United States, I think that was the same. The parrot that taught some words, and especially explicit, and yes, I love that. In my childhood, I remember, I can say
my father
on the show
told me sometimes that his grandfather has a parrot that always say to the dog that they have, shut up, and the dog say, ooh. No,
yes, but the parrots say another
no,
word.
yes, of course, no, yeah.
Yeah.
Right.
Yeah.
But well, guys, I think I had to go to bed. I hope this short presentation was
it's great. It's great.
It was an amazing 90 global star party.
Yeah, thank you so much. Thanks everybody. I think that we had some new people on. That was very interesting, of course, to all of us, but it's always great to be back with old friends, and we'll do it again next Tuesday for the 91st Global Star Party, and with the theme of stellar streams. We've talked about it a little bit on this program, and you saw a little bit of imagery that would hint at that, but of course there's many meanings to the our themes, and it's all meant to be talked about from the different perspectives and lenses of our presenters. So until that time, you guys take care, keep looking up. We'll sign out now, and hope to see you back next Tuesday night. Take care.
Bye.
you